Hello students, good morning. Welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. So everybody let me know in the comment section if I am clearly visible to you and audible to you. Right? Is my voice clear to everybody? It's completely audible. Right? And am I completely visible to you? Is there any lagging or anything? Then let me know in the comment section with the starting of this lecture itself so that we can do block chemistry. Right? So block chemistry means DNF block, P block, right, and periodic classification. We will start from periodic classification because that is a general thing that you should know before starting DNF block, right, and P block. Firstly, periodic classification, then we will start with P block. Then after that, we will do the questions of periodic classification and P block because most things you will see are similar. After that, we are going to see DNF block, right? So everything will be covered here. Let me show you what we are going to do here. See, actually, today's lecture is a combination of everything that I have done till now, right? In a very short manner, I'm going to do that. First thing is, right, the important parts that were not summarized in NCERT that I'll summarize for you, right? The trends that are written in the tabular form, I will write that not in the tabular form, but in the written, the trends, like, okay, what is the first, what is the second, third, fourth, like this, not in the values, but according to the trend. I'll mention some exceptional trends. We will talk about oxides, amphoteric, all of these things. We'll talk about in DNF block some of the questions that are not related to trends, but in DNF block they also ask you other questions except for trends, okay? Because there are only 2-3 trends, right? So what kind of questions they ask you, all of that we are going to discuss today. If you are ready for today's session, then let me know in the comment section. Yes, Surva, I am absolutely fine. I'm absolutely fine. Right? Don't worry. Is my voice low? Is my voice low, students? Let me know in the comment section because I don't want to have any disturbance in between the class. Right? Once we start the session, if there is any disturbance, then let me know. Yes, ma'am, low voice. Lecture duration. Lecture duration, I think 2 to 3 hours maybe. Maximum 3 hours. I'll try to sum up this lecture by 1 p.m. Right? Okay? Okay, ma'am. No, ma'am. It's perfect, ma'am. Hello, hello, hello. Hello. I think it's perfect only. If there is still any problem, then let me know in the comment section. You continue? Okay. No, ma'am. It's okay. It's fine. Okay. If there is still any problem, then you can let me know in the comment section because once I started, I hardly will see any chat box in between. I'll definitely ask you, right? So these are the 3 topics that we are going to cover today. And how it is going to give you 32 marks? Definitely, they will ask you at least 6 or 8 questions from this full block chemistry, right? So that is how this becomes very important for you, right? And we can never skip periodic classification. If you're doing block chemistry, you have to do full block chemistry here. And in block chemistry, it's not like you have to touch every single part of the lecture. So that's why only some important parts we will touch today. That will be, you will definitely see in your exam. So this is your periodic table, right? And those students who have no idea about, ma'am, what is periodic table, I have no idea, those, just relax yourself, give me your 3 hours, and after these 3 hours, you will yourself be able to solve all the questions. Because today we are also doing the questions, you will yourself realize that what kind of questions they ask, right? Okay. So periodic table of elements, as you can see, this is the periodic table. Now what you have to learn, ma'am, should I learn the full periodic table? No. You have to learn group number 1, group number 2. Then you should know period number 1, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Till here you should know the trend in this one. Then you should know the 3D series. This is must. Okay, 3D series, group wise, these 2 things are must for you, right? Then all these groups, all these P block elements, group wise, you should learn that what are the elements in boron, carbon family, nitrogen family, oxygen family, fluorine halogens family. Okay, you should know that. Then you should know this lanthanoids as well, right? Okay, so these are some things that you must do. right? Ma'am, how we are going to do it? If you have any of your mnemonic, then let me know in the comment section. If you don't have any mnemonic, I'll tell you here, right? If you think that, ma'am, I want mnemonic in English, then you can just write it down English here after the end of the class, right? I have already charts. I have charts where I have already prepared mnemonics in English as well, right? So if you want mnemonics in English, I would advise you, rather than English, go into your regional language, okay? In your regional language, whatever is your regional language, your mother tongue, try to make mnemonics in that, and try to make mnemonics yourself. Why? Because that will help you. It's your story of life. Try to relate it to your story of life so that you don't have to learn the mnemonic. Mnemonic are supposed to be easy for you. Like, but still, if you say, ma'am, I don't have enough time to do that, then see this. In Hindi, I am telling you right now. In English, I'll send you one table, one chart where I'll write all the mnemonics. You can go and learn that. After the class, I'll send you that, right? Okay. You can just spam that in English, right? Okay. So after the class, I'll send you that, right? Here, this is Leena ki Ruby se friendship. Beta mange car, scooter, baap, razi. बाल गए इंडियन तेल, देन काशी गए संत प्रभु, ना पी ऐसी शराब भाई, उससे टेपो, फ्लोरीन क्लोरीन ब्रोमीन आयोडीन, right? That's it. Okay, this is how you're going to remember all the things here. And what about 3D series? Saktiv, Karman, Fiko, Niku, Jan. Okay, that is how easily you can remember that. These are very famous mnemonics. Okay, but if you feel that English, you can just spam it down in the comment section as well. I'll send you the chart on the Telegram, right? Okay, now let us talk about the trends now. Okay, you have to understand things and go through whatever I tell you, right? Now, firstly, I'm going to tell you some generalization here. We have 4 things that they usually ask you. One is atomic radius, other is ionization enthalpy, then electron gain enthalpy or electron affinity also, and last one is electron negativity. So these are some general things that you should know, right? Okay, so by very simple thing we will understand here that along the period means this thing, this is down the group. So always remember, along the period, just remember one thing. If you like, ma'am, I am not able to understand the trends only. Just remember, fluorine is the most smallest atom in the entire periodic table. It is the smallest atom in the entire periodic table. So what you will say that if fluorine is the smallest atom in the periodic table, that means along the period, the size is decreasing. Okay, what you have to remember here, just one thing, along the period, this is what they don't even ask you, but you should know this, because if you don't know the general trend, you won't be able to understand the exceptions here, right? Period, the size decreases, and down the group, the size increases. Okay, that is a general thing, right? Why this happens? Because along the period, Z effective increases. You are adding electrons here, right? Okay, one electron you are adding. That is why you can say that along the period size is decreasing here. Okay, just one electron you are adding, right? Down the group you are adding fully one shell. Like this is 1s2, right? Here it will be, then it will be 1s2, right? 1s2, 2s2, then 1s2, 2s2, 2p6, 3s2. That means a whole new orbit you are adding here. So that means huge amount of electrons you are adding. So the size is going to be larger. This is how you can understand this, right? Now, let us see the exception here. Now, ma'am, you said that fluorine is the smallest, but ma'am, we have halogens in the end, so noble gases in the end. So noble gases should be the smallest. But in noble gases, they have van der Waals radius. And that is the reason they have van der Waals radius. That is the reason we know that along the period size decreases, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, it is decreasing. But noble gases have the highest among the period. Reason? Because of they have van der Waals radius. They are not forming bond with each other. They are interacting. Different molecules are interacting by van der Waals forces. Okay, so that is going to be very important part. Next is, as you can see, exceptions I have already written here, right, for you. So what you will see here, for representative metals S and P. So when you talk about, they will ask you questions from trends, they will ask you from S and P block, right? S block is not in your syllabus, right? That is why some of the important trends of periodic table along the period you should know, right? So that is why here, if you talk about the S block here, it is very simple that down the group it is increasing. Down the group it is increasing. Down the group it is increasing. Simple, no exception here. But if you see group number 13, here you will see some exceptions. We will also talk about group number 13 in P block as well in detail, rest of the things. But this is a very, very important question that they frequently ask you even in this JEE means, this attempt, right? NTA was conducting the same exam, right? NTA is conducting NEET also, right? But still they are asking this question there also in every single shift, right? So this is a very standard question, right? That is, it should be BELGAIN, then TL. It should increase down the group. It should be like this. Okay, it should increase down the group. It should be like this. Okay, but exactly what is happening? Aluminium and gallium, they are interchanging their position. Okay, aluminium and gallium, they are interchanging their position, and the radii of indium and thallium will become almost similar. Now, reasoning in most of the questions you will say poor shielding effect of d orbital, poor shielding effect of f orbital. So for that you have to just give me 1 minute to understand what is poor shielding effect, okay? Because the reasoning is going to be same everywhere only, right? So just understand one thing. So basically what is happening in the nucleus, we have very high positive charge, which is very dense, very small but very dense, right? And here electrons are revolving here in the orbit, right? So this nucleus, this positive charge is attracting the electrons. It is attracting the electrons because of electrostatic forces, right? Now, if some bodyguard is in between them, then I will not let you guys interact. It's like there is this boy, there is this girl who is like, okay, rotating, aise, butterfly, like a butterfly, going here and there. Now, this boy is like, oh my God, I like this girl. Then he is trying to attract her, right? But now in between are girl's brother, okay? Girl's brother. Girl's brother is the bodyguard, right? So he will not let this positive nucleus to attract the electron, right? That is shielding, protecting, right? So the inner core electrons, they protect the outermost electron from the nucleus, right? And if you talk about the shielding effect of S is greater than P, then D, then F. That means when you have d orbitals, we know that here we have the starting of d orbitals. That is the reason d orbital electrons have poor shielding effect. That is why the size of gallium is greater, is less as compared to aluminium. Why this happens? Because in gallium there is poor shielding effect, right? The brother is like, oh my God, don't look at my sister, then do nothing, okay? Just giving fake dhamkiya, nothing like very new, right? So the brother is not able to protect the sister, right? So that is why it is poor shielding effect. So that is why sister got attracted to that nucleus. Now the size is decreasing because attraction, right? So the duriya is decreasing basically. Duriya means we can say yeah, what is that? I've sometimes forget. Sometimes I get deep dive into chemistry so much I forget some normal names only, right? Okay, so here it is. Next is here. This is because of 3d electrons poor shielding effect. This is because of 4f orbitals poor shielding effect. So similarly, when you go towards lanthanoids and actinoids, if you see this periodic table here, if you see this, here you have lanthanoid, here you have actinum. So from here you have the starting of lanthanoids. From here you have the starting of actinoids. So we know that before thallium you have lanthanoid and 4f orbitals has even poor shielding effect, right? Such a bad brother he is. That is why the size is decreasing. And this is what we call lanthanoid contraction, right? Because of this 4f orbitals, the the nearest atoms, right, that are after the 4f orbital, those elements, the outermost electron is not able to get protected by the 4f orbitals because of Bohr shielding effect. Hence, the size will decrease here, right? Okay, yes, okay, very good. Now, let us see other things. Now, rest of the things are same here. Kasi gaye Sun Prabhu, this is also same. Napi, all these are same only, okay? The one that was the exception that I have told you here, okay? Next is, in detail, we will do the exceptional trends, don't worry, okay? Now, next is atomic radii along the period. So, this is D block. In D block, what you will observe, that till group number third means till here. Till group number third means till here. Ma'am, why till group number third? What they want to say? Because till group number third, there is no lanthanoid series, there is no actinoid series, right? Okay, so till group number third, what we have is till group number third, 3D, then 4D, then 5D, size is increasing down the group. But group number 4 to 12, fifth period and sixth period, that means 4D and 5D series have almost same radii. That means example is Hoffman and zirconium has the same radii. Okay, so what you will see here also, let me just show you this thing here, because see, every time I have to open this periodic table. Now what you will see, that this is your lanthanoid and this is your actinoid, right? Can you locate the lanthanoid and actinoid here? Yes, can you locate? This is lanthanoid, this is actinoid, right? Lanthanoid, actinoid is there. Now, they are saying till group number 3, it is decreasing. But after group number 4, that means 4, 5, 6, 7, what you will see, because of this lanthanum and lanthanoid series and actinoid series, because of the poor shielding effect of this 4f and this 5f orbital that is there, that is intertransitional elements, right? The size of hafnium, zirconium, all these sizes become automatically same with each other. That is, this zirconium and this hafnium become same, because to these elements, one simple concept will occur, that is lanthanoid contraction. Lanthanoid contraction. Okay, one simple concept, that is lanthanoid contraction will occur here. That is why the size will become almost similar here, right? Next is, this we have done. Next is 3D series. Now, if they ask you the size of the 3D series, now remember, firstly, what will happen? The size will decrease till manganese. The size will decrease till manganese. After that, for Ficoni, it will remain constant. And after that, it is going to increase, right? The size will remain decrease. It will start decreasing till manganese, right? After that, for Ficoni, that is iron, cobalt and nickel, it will remain same, because shielding effect and Z effective will be equal to each other. Here, why size is increasing? Why size is increasing here, right? Because here one thing is dominating, right? Okay, sometimes of what we will see here, size is decreasing because Z effective is dominating, right? Here size is increasing because shielding effect is dominating. So that is how it will go, right? Okay, next we have is, now they also ask you questions like this, okay? Questions like this. Now what are these kind of questions? These questions are when you have four elements from different groups, they will say. Now you will get confused here, right? So how to answer this? So firstly, you will see that along the period size decreases. That is why these two are going to have less size as compared to these two, right? So that is why here I have calcium and silicon, right? That is going to have less size here, right? Okay, that is going to have more size, right? Now here if you see, this is increasing down the group. That means boron has less size as compared to aluminium. So here it will be boron, right? Then you will have aluminium, right? Then you will have carbon, then you will have silicon, right? Okay, that is how you're going to answer Okay, right? But boron and carbon, this has two less size, this has more size, it has less size. No. Firstly, you have to go through periods only, okay? First, you have to, because these two also size we have to see because there has a lot of difference now. So here, this belongs to group number 13, this belongs to group number 14, right? So you have to see this also. If you see this out of boron and carbon, this is aluminium and silicon here. Aluminium and silicon, boron and carbon, we know that this has less size, right? Because size is decreasing. Here also, this is the size. Down the group size is more, so first it will be aluminium silicon, then it will be boron carbon. That is how you will write the answer here. Here also, this is period, right? So out of these two, we know that size is decreasing. And down the group it is increasing, so maximum will be for phosphorus, then sulfur, then nitrogen, then oxygen. That is going to be the answer here. Is that clear? Okay. Yes. Size increases down the group, along the period it decreases. Next is isoelectronic species, which is again a very important topic for you. So in this case, they will ask you, they will give you some cation and anions, and they will, this is a very frequently asked question, right? Okay. So for this, you just have to remember this simple thing here, that the size of isoelectronic, that means which has the same number of electrons. If you calculate the number of electrons, here it will be 7 plus 1, 18. 16 plus 2, 18. 19 minus 1. Calcium is 20 minus 2. Again, it is 18. So, all have 18 electrons. So, now what you have to see here, that it is directly proportional to negative charge. That means S2 negative, then you have Cl negative. It is inversely proportional to positive charge. More is the positive charge, less will be the size. So, here it is going to be, this is going to be the correct order. Similarly, in this case, this is having how many electrons? If you see this here, 7 plus 3, 10. Again 10. Oxygen is 8 plus 2. Magnesium is 12 minus 2. Aluminium is 13 minus 3. Sodium is 11 minus 1. So again, all of these has 10 electrons, right? So here again, if you see, negative charge will have more size. So it is N3 negative. Then it is O2 negative, because as the size, as the charge decreases, size decreases, right? Now we have the positive charge. Less the charge, less the positive charge, more is the size. So that is why it is going to be sodium, then magnesium, then you will have aluminium here. Okay, this is a very, very important question. Very, very, very important question. You will see this so many times in your previous year question. Okay, understood or not, everybody? Understood or not? Right? If that is clear, then let me know in the comment section, because we are going towards the next important thing, that is ionization energy. Now, what is ionization enthalpy, ma'am? Ionization enthalpy means you have an atom, right? Outermost electron, you want to take that electron out. That is ionization energy. Okay? So, to take the outermost electron out of the atom is called ionization enthalpy, right? Now, they will not ask you definition. They will ask you the irregular trends. Regular trends, they are not going to ask you. And you know what? Sometimes they confuse you. Sometimes they will ask you regular trend, because they know that you will think that, ma'am, they will not ask regular trends, but actually it's a regular trend only in the option. That is why you should know that where you have exception, where you don't have exception, right? So if you see along the period, okay, so along the period, try to focus on along the period more as compared to group, because group automatically I'm going to cover in P block as well, right? Okay, so here it is along the period, second, third and fourth period, what you will see that, ma'am, ionization enthalpy, always remember one thing, if something is already, let's say it is in P3, or let's say it is in D5 or D10 configuration. So if you have one atom in which electronic configuration is fully filled or half filled, then it is not easy to take out electron there, right? So if you see here, it should be that, ma'am, always remember one more thing, I'm writing it here only, right? Radius is inversely proportional to ionization enthalpy. That means the trend for ionization enthalpy is opposite, is inversely proportional to electron gain enthalpy. Gain enthalpy to gain the electron is inversely proportional to electron negativity, right? So if you remember the general trend of radius, rest of them are opposite to that. So what you have to do here, you can just directly say that radius is decreasing. That means along the period ionization enthalpy should increase, right? So it should increase like this: lithium, beryllium, boron, carbon, hydroxide, fluorine, neon, right? But in reality, you will see difference here. You will see difference here. In reality, it is boron is less as compared to beryllium, oxygen is less as compared to nitrogen. Now, why so? Why beryllium is more? Because beryllium is 1s2, 2s2, a fully filled configuration. Nitrogen, students, that is 1s2, 2s2, 2p3, a half filled configuration. So whenever something is stable, you can't take out electron from them very easily, right? So that is why here you will see abnormal trend in these two cases. Similarly, here you will see abnormal trend in aluminium and magnesium, and you will see sulfur and phosphorus here, and this is okay, calcium and gallium, and this is arsenic and selenium. Here you will see the abnormal trends. Till now, they have asked you question from this side. They have asked. Till now, these two they have not asked. Okay? Till now, these two they have not asked. That means they can ask you. That means they can ask you if they want to. As I told you, that they can't make a new trend, but they can give you the same trend that they have asked earlier. Either they will give you the same thing if they want to ask something from this, or they will give you from period number 3 or period number 4. So it's not like you have to just this only. Do this and this as well, third and fourth period also. Rest is same. For fifth period, it is increasing. For sixth period, it is increasing. There is a regular trend. There is no irregular trend here. Okay? There is regular trend. There is no irregular trend here. Right? Okay? Yes. Next is, okay, ionization enthalpy along the group. So these two ionization enthalpy is what they are obsessed with, right? I think every exam is obsessed with the ionization enthalpy of group number 13 and group number 14. Ma'am, what is the reason? Reason is same. Reason is same. Poor shielding effect of d orbitals, poor shielding effect of 4f orbitals, same reason, right? Same reason everywhere. Now, ma'am, what is this trend? Why this is changing? So I'll just tell you here. So it should be first, this trend of group number 13 is very important because this is a very weird trend. You have boron, thallium, gallium, aluminium, indium. What is this? Right? It should be BALGAINTL. So it is BTL, then you have GA, then you have AL, then you have IL. So there is not at all regular trend, and that is why students make mistakes here, and that is why they ask you this question. And for this, a general thing to understand how to remember this is W. Okay, just remember. For example, you have a W like this. Okay, this is how you draw the W. Now you will stretch this W from here, and it will be like this. It will be like this. Okay. Now you have to write down all the elements here: boron, aluminium, gallium, one by one, indium, and thallium. Right? Now you should see which is first, which is second. First is boron, right? Boron. Then you have in the line you have thallium, right? Then in the line you have gallium. Boron, thallium, gallium, aluminium, and then you have indium. You have to see horizontally which is coming first. Boron, thallium, gallium, indium, aluminium, and indium. Okay, that is how you can remember, or you can also remember it like this: 1, 5, 3, 2, 4. Okay, 1, 5, 3, 2, 4. If you're good with numbers, do it. If you're good with diagrams, do that. Totally your choice. Two choices I have given you. But this trend was repeatedly asked in JEE Mains also. That means right now their mindset is of this level. Okay, right? So they are asking you repeated questions, right? But my idea is I think that I have a feeling that they will not ask you one trend. They will give you match the following here and they will ask you 3-4 trends. That is what I think, because they will definitely make a good level of paper. Okay, good level does not mean they will ask you something out of syllabus. Good level means they will ask you in one question, they will try to ask 3-4 questions. Okay, right? So that is why here these things I have already told you, that why this is so, why this is so, pore shielding of D, lengthenoid contraction, lengthenoid, all the reasons are similar reasons. Okay, so next is ionization enthalpy in 3D. Now here also, ma'am, it is very weird, ma'am. How it is weird? Firstly, it is increasing, 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 right? Then it is decreasing, then it is decreasing, then again it is increasing, then again it is increasing, right? Okay, so that is something. Here also it was decreasing. Okay, here also it was decreasing. So ma'am, what you are saying, should we remember this diagram, this. Okay, that will be very difficult for you to remember, right? Those many diagrams we can't remember, guys. It will be like I am making things more complex for you, right? That I don't want. So you know that along the period, ionization enthalpy increases or decreases. Let me that in the comment section. Ionization enthalpy decreases or increases along the period. Let me know. General trend you have to tell me. General trend you tell me. Karman fi ko ni ku jan. Ni ku jan. Yes, the trend increases or decreases? Yes, students, the trend is increasing along the period. Okay, it should be increasing, right? Okay, this is what is happening. Now just remember one thing, that is Viconi. Viconi. What you have to remember? Viconi. Viconi. What you have to remember? Viconi. Right? So that means in front of V, it will change. In front of CO, it will change. In front of Ni, it will change. That means in all these cases, this, and this, it is going to be opposite here. Rest of the things will remain the same. Okay, rest of the things will remain the same. That is how you're going to remember the trend of 3D series ionization enthalpy. In 3D, you just have these two trends. That's it. Okay, in DNF block, that's why I'm telling you that I am completing most of the trend in the starting of the lecture, because in the ending part, I have to tell you some things that are not trends, but that are there in block chemistry. So you just can't rely on trends. See, if you want to get 60, 50 plus marks, if you're targeting to, ma'am, I want to gain 170 plus marks in chemistry, then you can't say that, ma'am, I'll just do exceptions, right? That is for those students who want to have 500 plus marks or maybe 550 plus marks. You can just do exceptions, right? But if you can do things that are beyond exceptions, right, that they will ask you in the exam, that will make you a hero, right? So that is why we are here to make you heroes. Exception, so you can do yourself also, right? What's the big deal in that, right? Now, next is ionization enthalpy. This we have done. This also we have done. This also we have done. This also we have done, right? Okay. Now, next is electron affinity. Now, anybody who knows what is the difference between electron affinity and electron gain enthalpy? Biggest problem students are like, ma'am, we don't know what is electron affinity, electron gain enthalpy. How many of you had your breakfast? How many of you had your breakfast and what you had in your breakfast? Yeah, I had, I'll tell you. First, you tell me what you had in your breakfast. And if you didn't have breakfast, then also tell me in the comment section, in the chat box. So, when you are craving for breakfast, or you have still not had your breakfast and you are craving right now for breakfast, that means your affinity to eat something is positive. You are like, I want to eat something. You're like, I'm hungry, right? Give me something I want to eat, right? Then that is your affinity. But if I give you food, your mama is like, okay, you are studying. Oh, yaar, dosa, yaar. You are making me feel very jealous, Chandu. Chandu is making me feel very jealous, right? Okay. Yes, ma'am, dosa. Everyone has dosa. Yeah, please send it to me also. Yeah? Send it to me, dosa. I love dosa. Why are you eating dosa alone? Send it to me also. Dosa, ma'am, deserves dosa, right? So send it to me with coconut chutney and sambar, right? Best. Now I am what? I am very eager to have affinity for the dosa, right? My positiveness for my affinity for the dosa is to this level, right? That means when you will give me dosa, ma'am, here is your dosa, ma'am. Then I'll be like, oh my God, I'm eating that dosa and I'm very happy. So I'll release energy. I'll be very happy. I'll be on cloud 9, right? So I'll be very happy. So that is my electron affinity, my dosa affinity is positive. So my uh, electron gain enthalpy, that means dosa gain enthalpy, when I eat that dosa, right, that is going to be negative. That means I am going to release a lot of amount of energy because I am happy. So now if I say that, you tell me that dosa, everyone had dosa. Now you're making me feel very, very jealous, right? Okay, so I'm literally right now, I have water in my mouth because of that. Okay, I'll just drink some water. Isn't it? Should I drink water? I'll drink water thinking that it's dosa. Okay, now if I say that, you give me, ma'am, there is no dosa, ma'am, eat, ma'am, this khichdi, right? So give me, ma'am, eat this khichdi. I don't like khichdi at all, right? Even if I'm like ill, I hate khichdi even then. I'll be like, I'll starve, but I'll not eat khichdi. I hate khichdi to that level, right? But yes, you have to eat it when you're not well, right? So when you give me, ma'am, I have made dosa, ma'am. I'm eating dosa. I'm like, oh, my affinity is not good. I don't want to eat dosa. My affinity is negative, right? Then you forcefully say, ma'am, you have to eat, ma'am. You're not well. You have to eat, right? This is what your mama does now. So when you're not well, you're like, I don't want to eat khichdi. Then your mama is like, you have to eat, right? So it's not like after eating khichdi, you're like, la, 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 la. No, nothing like that. After eating khichdi, you are like this. Yes, I ate khichdi, but I'm not happy about it, right? So that means after eating khichdi, you will not release any energy. That will be positive, right? Okay. So that is how best way to remember what is electron affinity, electron gain enthalpy. That is why the signs of electron affinity and electron gain enthalpy are always opposite to each other, right? Now, let us see for p block elements, electron affinity of second period element is greater than electron affinity of third period element. That is this. That is a standard thing, right? Can you tell me why? Can you tell me why? Right? Here it is affinity is greater, right? Because here it is NS2 NP1. Here it is NS2 NP2. Now see, after gaining one electron, it will be shifted to NP2. Here after gaining one electron, it will be shifted to NP3. That means to a stable configuration. Now, if you are getting stable after eating dosa, you are getting happy. So that is why your affinity will be very high after eating dosa, right? So that is why this is affinity of third period is greater as compared to affinity of second period. Is that clear? Okay. Yes. Okay. Yes. Very good. Now, next is some of the important. Now I'll tell you very frankly here, right? Let's be very clear, right? On your mouth only, I'll tell you no this and that stuff. That okay, I'll give you some fake things here, like giving you like okay, this will definitely come in the exam. No, nothing like that on this channel. Okay, be direct, right? So let me be very clear. This they have never asked, right? This they have never asked because this is actually very difficult. This they have asked. This they have asked. These two they have asked. Okay. For electron affinity, only some of the trends are important. For here you will see boron, aluminium, gallium, indium, thallium. Right? Right? That means boron, this also they can ask. Yes, this also they can ask. This also, this was not the one they have not never asked. Now here it is carbon, silicon, germanium, tin, lead. Okay. This is also very weird trend, right? Then you have definitely because third period is greater, right? So why third period is on like on the first aluminium, then silicon, then phosphorus? Why so? The reason is because after gaining one electron, it will get to a stable configuration. That is the reason. Okay, that is why these are the exceptional trends here, right? Okay, here you have phosphorus, nitrogen, arsenic. Then you have Sb and bismuth, right? Tungsten and bismuth, right? Okay, that is how you, tungsten I'm saying, okay, I'm so sorry, antimony and bismuth, right? Okay, now these are the trends. You must go through this, but they are not very important. Okay, the very important trends are these two, very, very important, right? Okay, this so definitely they will, like, they one or the other year they ask these questions, okay, regarding electron affinity. So here it is for oxygen family, right? Even for nitrogen it is very important. See, nitrogen, then phosphorus, then na pi aisi sharab bhai, right? Okay, that is also because of third period is more as compared to second period, based on that only. Now here you have oxygen us se tepo. So basically here what you will see what are the differences that you can see here. Here the first element is on the first position. Here the first element is on the second position. Here it is on the last position, right? Here also the first element is on the second position. So that is why there is very irregularity. Sometimes it is on the last position, sometimes it is on the second position. Rest of them are mostly same, right? Boron आल गए इंडियन तेल, का सी गए संत प्रभु, ना पी ऐसी शराब भाई, राइट? उस से टेपो, fluorine, chlorine, bromine, iodine. That means what you have to remember here, boron and oxygen are on the first. Just remember OB last, OB last. Rest of them like carbon, nitrogen, fluorine are on the second position. Just remember this. Okay, rest of them are same. Just remember these two things. See, beta, I'll tell you very simple things. Cramming all these trends is not possible, right? You are a human, you are not a machine, right? Okay, you are a human only, right? So you are not a robot who will cram all the thing and vomit it out in the exam, right? So you have to be very smart in this. So the smartness is just remembering that in boron and oxygen, it is coming in the last position. That is the exception. And in rest of the cases, the first element is on the second position. Okay, that is a simple thing, right? Okay, now here, next is group number 16 and group number 17. Now students, we know that group number 17 is NS2NP, NS2NP5. This is NS2NP4. Now here we know that after gaining one electron, it will be NP6, which is fully filled orbital. That is why group number 17 is like, I want to gain the electron. My affinity is very positive. I want to gain the electron, right? Okay. Now these are electronegativity. Na? Achha, one more thing you write it here. That is noble gases. That I was telling you, na, the electron affinity trends are not asked. That is along the period. Okay. If you see anywhere the trend of second period, third period, all of these regarding electron affinity, that is never asked. That is why I have not put it here on this page. Okay. Because I don't want you to study something which will not even be there in your exam. We are just 20 days away, right? So we have to be very smart in what we are doing right now, right? So noble gases, their electron affinity is positive. They are like, I don't want to gain any electron. I am already fully filled. I am already stable. Why would you make me gain any electron? That is why this question was also asked, that noble gases have electron affinity positive, negative. What? It has positive electron affinity. Now let us talk about electron negativity. So this is A, this is B. Electronegativity means you have a covalent bond, and let's say this is more electronegative. So in this covalent bond, the shared pair of electron will be towards B, right? So in a covalent bond, when the shared pair of electron is towards one of the species, one of the atom, that is electronegativity, right? Okay. So that is a simple chart of electronegativity, what you have to remember, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Just remember, for fluorine it is 4. Decrease it to 0.5, right? 3.53, 2.52, 1.51. Decrease it to 0.5, and you will get your answer. right? And nickel and chlorine is 3, right? Nickel, I am saying nitrogen and chlorine is 3. Cis, carbon, iodine and sulfur is 3.5 and HP, right? That is 2. Okay, just remember cis this, NCl this, HP is this. That is how you can remember, right? Or for my chemistry students, you can remember pH. pH is equals to 2. pH is equals to 2, right? Now, let us see the nature of oxides here. Now, have you ever done previous year questions and have you ever seen one question, one standard question that is on nature of oxides, neutral oxides, amphoteric oxides? These questions are asked. If you have done PYQs, then let me know in the comment section if you have seen these kind of questions or not, right? Okay, if you have seen these kind of questions, then let me know in the comment section, because I want to see if you are aware that what are the questions that they ask you. Only exceptions, no, right? These questions are also very important. So this is basically what we are telling you, that we know that, see, metallic character is like this. Along the period, non-metallic character increases, metallic character decreases. Down the group, non-metallic character decreases, metallic character increases. Metallic character means basic oxides, non-metallic character means acidic oxides. Okay, so over here you will have acidic oxides. Okay, over here you will have acidic oxides. Over here you will have basic oxides. Okay, basic oxides, right? And these are the amphoteric oxides. Okay, that means the oxides of metalloids. These are amphoteric oxides. Okay, so neutral oxides are CO, NO, NO2. These are the 3 neutral oxide, and you can add water also here. You can add water also here, right? Now you're like, ma'am, is this enough? Then I'll give you one simple from my handwritten notes, right? One simple thing, right? That is this, right? That is this. Now here what you will see, everything that you need for to answer after going through this page, I can promise you there will be not even a single question of oxides that you won't be able to answer, right? So what you have to remember first is remember the neutral oxides. You have carbon monoxide, NO, N2O and water. These are the 4 neutral oxides that you have, right? Then amphoteric, you have to remember this. Now this, I think my students, you guys have already told me one mnemonic for this one, right? If you still remember that mnemonic, then let me know in the comment section. I totally forgot, right? So because I remember it as it is only, right? Vanadium oxides are also amphoteric, chromium are also amphoteric, lead are tin, zinc and aluminium, all these are amphoteric in nature, right? Okay, so all जन work कर PBSN, okay? All जन work कर pubsun, I don't know, right? Okay, yes, yes, everybody. Any mnemonic here on this, right? I too can't relate to that, any mnemonic, right? Okay, so you tell me your Gen Z kind of mnemonic that you have for this one, right? This you have to remember. Then tin has this SNO and SNO2, lead is SPBO and PBO2, chromium is chromium in Cr2O5, vanadium in V2O5, then zinc ZNO, Al2O3, aluminium, right? These are the amphoteric oxides that you have. Rest we know that acidic oxides are from the non-metals, basic oxides are from the metals, right? Okay, next you have is acidic strength. Now students, we are going to cover some of the very important things here, right, that you will hardly see in your NCERT. Right now I'm going to cover something that is given in your NCERT, but it is given in some lines are there in chemical bonding, some lines are there in periodic properties, some lines are there in D block, some lines are there in P block, right? So that is why all of these things together, right, you have it, right? So now first is acidic strength of hydrides. Okay, if you talk about acidic strength of hydrides, so Hydrides, if I talk about, okay, hydrides, this is very, very important, very, very important. So acidic strength of hydrides, now understand one thing, down the group, what will happen, right? Down the group, the size will increase. That is why the power holding of H positive will decrease. The size, this is H, this is the other element. So other element you have this much size. So now hydrogen is very close to the other element. Now it is going away because the size is increasing. That is why the hydrogen is loosely bound to that atom. That is why it is easy to lose the hydrogen. And hence down the group what you will see, here too we have seen down the group. Let me see that. Yes, this is down the group, right? Down the group, how it is decreasing, right? This is also down the group, how it is increasing, right? How down the group, because of the size is increasing. That is why the power of losing H positive also increases. Hence acidity increases down the group. If you talk about along the period, now students, along the period, what we say? Along the period, that is because of the electronegativity. Here, because electronegativity difference is very large. You think opposite poles. You say that I want to watch, you and your sibling. Okay, you're like, I want to watch Cartoon Network. Your sibling is like, I want to watch some Bollywood romantic movie, right? So you guys are always fighting over the remote, isn't it? So that is why you are poles apart. You have very high electronegativity difference. So it's very easy for you guys to fight with each other, right? So that is why it is very easy to lose hydrogen atom here. And hence, one thing to remember for this is, along the period and down the group, both the cases, the acidity increases for the hydrides, okay? Yes, this because of electronegativity, this because of the size. Okay, understood this, right? Okay. Yes, definitely you can make, no worries in that, right? Okay, but after the exam, okay? Right now, focus on your exam, right? Okay, now basic strength of hydride. Acidic strength, we have seen basic strength. If you see the basic strength here, ma'am, it is decreasing. So basic strength is opposite to acidic strength. If acidic strength is increasing along the period down the group, basic strength will be decreasing here. Let's say you have along the, these are the examples that I am giving you side by side. You have NH3 and H2O. This is along the period down the group, doesn't matter. If this is a hydride, it is going to decrease, right? Okay, so it is along the period, it is going to decrease here, right? Okay, next is hydroxides. Till now we have done oxides, right? Acidity, basicity of oxides. We have done hydrides. Now we are doing hydroxides. Okay, now we are doing hydroxides. Okay, yes. Now let us see that hydroxide, students. For that, first is basic strength, right? Let us see that, and acidic strength as well. So basic strength is depending upon the metallic character, inversely proportional to non-metallic, which is directly proportional to acidic character, right? Okay, that we know. Now along the period, our basic strength decreases. Okay, you just remember the acidic strength. I would advise you to remember just one thing, right? So for hydroxides, just remember that along the period, acidic strength increases, and group you can say acidic strength decreases, right? Okay, just remember along the period, acidic strength increases because non-metallic character increases. Haven't we seen that non-metallic character along the period it increases? So acidic strength will increase, right? Okay, so if you see this here, this is along the period of what? Lithium, beryllium, boron, aluminium. Yes, this is along the period. So it is, wait a minute. This is basic strength or acidic strength? This should be basic strength. Yes, basic strength. Okay, I have not mentioned it here. This is basic strength that is decreasing, and here it is down the group. Down the group, what you have is down the group. Again, this is basic strength. Okay, both are basic strength. So if they ask you the basic strength, we know that basic strength along the period, the basic strength will decrease. along the group, the basic strength will increase, right? Okay, this is what you have to remember, right? So till now, what we have done, oxides, hydrides, and hydroxides, right? Next is the trends here, right? So if you see along the period, right? So here we are talking about the oxides only, right? So basically this is oxides only. The trends of the oxides, we have seen the oxides, neutral oxides, amphoteric oxides, basic oxides, everything. But now let us talk about the oxides in general. What is the trend? So if you see this, sodium, potassium, right? This is period. This is group number 1. This is group number 1. And if you see this, this is what? Group number 2. Group number 2, right? So we know that along the group, the basic strength, if you talk about along the period, the acidic strength increases. Reason again, because of non-metallic character is going to increase. Rest of things are opposite. That is why basic strength will decrease along the group. Basic strength will increase because it is opposite. Here it is increasing, so here it will decrease. So you have along the group, they are asking you the basic strength here. So basic strength along the group, that is down the group, right? Because metallic character is increasing, that is why basic strength will increase here, right? If you talk about along the period, right? Let's say down the group only, they are asking you the acidity. Down the group, the acidic strength will decrease because non-metallic character is decreasing here. That is why it is going to decrease. So this is what you have to remember. Next is, till now what we have studied, everyone, let me just summarize it for you. So I'll summarize in the end only. We have just 3-4 pages we are left with. In the end only, I'll summarize that, right? So now let us see the oxides of same elements. Now what if they ask you this kind of question also, they ask that you have oxides of the same element. Now they ask you which is more acidic, right? So for that, always remember acidic strength is directly proportional to number of oxygen atoms, or you can say directly proportional to oxidation state. You can calculate the oxidation state if you find it easy. If you find it, ma'am, okay, is there a simpler way of doing this? So you can directly say acidic strength is directly proportional to number of oxygen atoms divided by number of central metal atoms, right? Okay, so here if you see, this is 2 divided by 1, this is 3 divided by 1. This is greater, so acidic strength of SO3 is greater. This is 5 divided by 2, this is 3 divided by 2, again this is greater. This is 1 divided by 1, this is 3 divided by 2, this is 2 divided by 1, right? Okay, so 3 divided by 2 is 1.5. So that is going to be the answer. This is direct way of doing things. If you're like, ma'am, I don't want to do this, ma'am, what is the, or how to calculate oxidation state? So we know that x is equals to minus 4 is equals to 0, x is equals to 4. So here it is 4. Here it is x minus 6 is equals to 0, it is 6. So that is why this is greater as compared to that. So that is totally your choice how you want to do it, right? Okay, that is totally your choice. And next, let us do this also, right? Acidic strength of oxyacids. Oxyacids of phosphorus and sulfur are very important for you, right? See, in P block, they have not mentioned it in the syllabus, but chances are they can directly ask you question from oxyacids of phosphorus or sulfur, right? Okay, so let us see this. Firstly, it is period. We know that along the period, acidic strength increases and group acidic strength decreases. That we know, right? So here, that is the general way of doing trend of oxyacids. So if you see this, see if you have different central metal atoms, then you have to follow this thing. We know that this is the carbon, phosphorus, sulfur, chlorine. So we know that chlorine is, if you see, this is carbon, this is phosphorus, this is phosphorus, this is sulfur, and this is chlorine here, right? Okay, so here you can't answer it like that. Yes. Okay, you have to also see that whether they have, which has very high oxidation state, right? So you also have to calculate the oxidation state here. That's how you can answer this, right? That also makes a very important thing for you. So this is HCl4 maximum, right? Then you have H2SO4, then you have H3PO3, then you have H2CO3. Right? That is the general order that you should know, right, in the mineral acids, right? Now, if you talk about this is sulfur and selenium, there is actually some period or group trend. Okay, so sulfur and selenium, right? We know that it is it is down the group. Down the group, non-metallic character is decreasing. That is why acidic strength is decreasing here. That is why it is less than as compared to selenium. That is why this is the answer that you get here. Right? Is that clear to everybody or not? Students, is that clear? Now, very, very important thing here. If you have same central metal atom, then that again depends on the oxidation state. So that depends on the number of oxygen atoms, or you can say the oxidation state of the central metal atom, right? So here oxygen atoms are 4, 3, 2, 1. That is why this is the acidic strength. Here 3 and 2, this is the acidic strength. 3 and 4. Wait a minute. This should be greater, right? Okay. So this is the acidic strength here, right? Okay. You can also calculate the oxidation state if you are getting confused here. So this is 2 plus x minus 8 is equals to 0. X is equals to plus 6. This is 2 plus x minus 6 is equals to 0. X is equals to plus 4. So this is plus 6. This is plus 4. Definitely this is going to be more as compared to H2SO3. Now, this is one of the exceptions. Okay, this is the exceptions that you will see here. This is the exception that you will see here. What is the exception? H3PO4, H3PO3, and you have H3PO2 here. Now, here oxygen numbers are maximum. Still, you have minimum acidic strength here. Right? This is the exception. Okay, I'll write it here. This is the exception. And from here, they ask you the question. From here, they ask you the question from the acidic strength of the oxyphosphorus acids. Okay, why it is so? Let me just draw the diagrams here. H3PO4. H3PO4. Firstly, ma'am, how to draw the diagrams here of H3PO4? Firstly, draw phosphorus. Then we know that always there is a double bond O over here. Always. Now you're left with how much? You're left with H3 and O3. Right? So you will write OH, OH, OH over here. Right? Okay. Next one is, ma'am, we have H3PO3, H3PO3, right? Okay, students, let me know in the comment section if you are able to draw the diagram of H3PO3. How many of you are trying this to draw the diagram yourself? Okay, because this is, you can't say, ma'am, this was not mentioned in the exam, because this is there, right? This is there, right? No matter it is not directly mentioned in your syllabus, but these acidic and basic strength are in periodic classification trends only, right? So this is P, this is P, this is double bond O, right? So you are left with H3 and O2. So here you can have 2 OH and 1 H here, right? That is how you can complete H3O2. Firstly, you will draw OH. Then the atom that is left, if you have one hydrogen, that will be one hydrogen here. Last one is, I think, H3PO2, right? So here again, what we have? P double bond O, right? Now you're left with, because you need to make 5 bonds here. You're left with H3O. So there will be OH and 2 hydrogens here. Now, reducing power depends on the number of alone hydrogen atoms that you have. Only hydrogen atoms that you have, that defines the reducing power or the acidic strength in case of oxyphosphorus acid. So that means the structure matters only here. This trick will matter in all the cases except for this one. This is the exception. Okay, reason is this thing, that is, it has no hydrogen. That is why minimum acidic strength. It has 1 hydrogen. It has 2 hydrogens. That is why you have H3PO2. Then you have H3PO3. Then you have H3PO4. That is the acidic strength. That is the acidic strength. Okay, that is the acidic strength. Is that clear to everybody or not? Is that clear? Okay, students, right? Okay, yes. Pradeep, don't worry. Tomorrow, yes, tomorrow, I think at around 6 p.m., right? I have already made the full 20 days planner for you for chemistry, right? So don't worry. In that planner, I have also given you the important points of physics and bio as well, right? So that planner is already, yesterday I made it. So today I will definitely record it. I think by today or maybe tomorrow. I think not today, maybe tomorrow. Yes, by tomorrow you will get that, right? Okay. Today is 11th now. I'll try to upload it by today only. I'll try to upload it by today 6 p.m. Right? Okay, if that is possible. Tomorrow is my promise that will be there on the channel. Right? So you can watch everything. Right? All the queries are solved in that video. Don't worry about that. Right? Right now, focus here. Next is we have started now P block. Okay, students? Most of the P block we have already covered. Most of the P block we have already covered, right? Now, group by group, I'm just going to tell you some of the points of NCRT that I didn't tell you in periodic table, right? Periodic classification, because group details also they ask you some very simple questions, okay? Yes, everybody ready for that? If you're ready for that, then hit the like button and smash just fill this, spam this chat box with green hearts. If you're ready for the next thing here. Right, students? Okay, if you're ready for that, yes, everybody, the energy should be high, right? You have eaten dosa, guys. Your energy should be very high, right? If I had dosa in the morning, then I would be like dancing here and there, right? Okay. So it's a rare thing for me. You guys are lucky. I wish I was born in South. Okay. Yes, everybody. I'll be quiet for 2 minutes because I need to give little bit rest to my throat. By the time I'll see that how many hearts you give me in the chat box. Fill this chat box with hearts. And now we are going to refresh ourselves. Everybody get up from your seat. Get up from your seat, walk a little bit, stretch your arms, right? Stretch your neck a little bit. And then after just walking for 3-4 minutes, then again sit down and study, right? And drink water, stay hydrated, right? Because that is also important for your body, right? You can't give too much burden to your mind, right? Okay. Yes. Let us start with the P block group. Group by group, we are going to discuss group number 13, 14, 15, 16, 17, and 18 here, right? If you see group number 16, right? Okay. Now here, if you see, some student is saying that, ma'am, can I get 650 from now? I am very weak. Achha, I thought 650. See, if your bio is very strong, these are all the things now that you have in your mind, ma'am. Can I score 650, this and that? Because that is possible. I am not saying that is not possible, but you need to be very clever and very smart. You need to know what are the topics you should do. You need to know what are the topics and from where you should do. You should know that what marks in chemistry you are targeting. You should know your weak areas. You should make bio your strong area. You should make chemistry your strong area. So that even if you are in physics, you are weak, then you can score, let's say, 330 marks in bio. You are scoring 170 marks in chemistry, right? These two areas are strong, right? Then definitely physics, even if you score less, you will make it to your MBBS college. So you need to have a proper strategy, right? And that I'll tell you in that video that I'm going to send you on the Telegram channel, right? Okay. So now here we have group number 13, that is here. As you can see, ma'am, this is very difficult. Ma'am, how to do this? So directly we'll see the table where we have written the trends. Okay, where we have written the trends for you. Let us see that table here. So trends and exceptions here. The first table that you have on your screen is atomic radii. Have we seen this? Have we seen this? Gallium and indium are interchanged here. Okay, gallium and indium are interchanged here. In this case, the whole ionization enthalpy of whole group 13 is interchange. Like it is nothing but it is that W that I taught you in the starting of the lecture, right? W that I taught you, that is 1, 5, 3, 2, 4. Directly you have to remember it like this, right? Then when we talk about electronegativity, it is, if you see this, electronegativity also has a very weird trend here. It is firstly boron is maximum, then thallium, then indium, then gallium, then aluminium. So basically what is happening here, right? In electronegativity, you have boron is maximum, then all gaye Indian the. That means down the group it is increasing. Down the group it is increasing, except for boron. Except for boron, which is having maximum. Except for boron, which is having maximum. Right? So side by side, I'm also going to write what you have to remember. This you will remember by W. This you will remember by that these two positions are getting interchanged. This you will remember that obviously down the group it is increasing. Electronegativity increases down the group. But boron has the maximum. Right? Okay? Yes? Now can you tell me why boron has the maximum? Anybody in the comment section? If you see boron exists in BF3, right? In BF3 kind of molecule. So it is forming 3 bonds. It always has 6 electrons. It is never able to complete its octet. That is why it is electron deficient. So it wants to gain the electron. That is why it is very, very clever. It is very electron deficient. That is why its negativity is very high, right? Then oxidation state. Now oxidation state, always remember one thing, that if you see this thing, NS, this is NP, right? So if you say, let's say you have group number 13, it will be 2 plus 1, 13. Group number 14, 2 plus 2, 14. Group number 15, 2 plus 4, 16. Group number 15, 2 plus 3, 15. Group number 16, 2 plus 4, that is 6, that means 16. Group number 16, 17. Group number 17, 2 plus 5, 5, 6, 7. Group number 18, 8, that means 6 plus 2, that is 8. That you should know one thing. Other thing is, if you see the lower oxidation state, this is general thing for all the groups. Lower oxidation state, and what is going to be higher oxidation state? And what is going to be higher oxidation state? Higher oxidation state will be N plus S. Sorry, I'm saying N plus S. Higher oxidation state will be P electrons plus S electrons, S plus P electrons. Lower oxidation state will be P electrons. Okay? Understood this thing or not, everybody? So I'm giving you general things here. Least you cram, more marks you will get in your exam, right? Block chemistry is not only about cramming, it has logics also. So down the group, always remember, down the group, lower oxidation state increases. Stability of lower oxidation state increases. You just have to remember this thing. Based on this, you will see so many questions in your exam, right? That is due to very, very good students. That is due to reason is, again, the shielding, that is inert pair effect. Inert pair effect. Okay? Understood? Now, let us see this. Oxidation states are, general oxidation state are +1, +3, because N and P are, S electrons and P electrons are 3, P electrons are 1, right? +1, that is lower oxidation state, down the group increases due to inert pair effect. The same line we will study in all the groups, same ditto copy paste we will do, right? Metallic character, we know that it increases down the group. Melting point, very, very important, right? Decreases up to gallium, then start increasing, right? So if you see this, boron, then aluminium, then thallium, then indium, gallium, very, very important. They ask you this question, that in group number 13, which has the lowest melting point, lowest melting point. In melting point and boiling point kind of questions, they ask you the lowest and the highest melting point or boiling point, right? Boiling point is decreases down the group. Okay, boiling point will decrease down the group. Simple. Density also increases down the group because size is increasing, right? Next we have is the properties here. If you see reactivity with air, right, reacts with air to form oxides at moderate temperature and nitride. Now this is very, very important that it reacts with air to form oxides, and with nitrogen it forms nitride, right? And crystalline boron is unreactive, amorphous boron reacts. Aluminium forms oxide layer and does not react further. These are some of the important lines from your NCERT, right? Next is reactivity with acids and alkalis. Boron does not react with acid or alkalis. This is a very, very important point, that boron does not react here. Next we have is aluminium reacts with both acid and alkali to liberate hydrogen gas. Aluminium is passive with concentrated nitric acid, right? With concentrated nitric acid, it does not react at all, right? Okay. Next is reactivity with halogens, right? Reacts with halogens to form trihalides, right? EX3 kind of compounds, trihalides, except triiodide of thallium, right? That means this is very important. This does not exist, okay? Triiodide of thallium does not exist. Thallium you have, it's triiodide, that means TLI3. Okay, I'll just write it here. TLI3 does not exist. Okay, does not exist at all. Is that clear to everybody or not? Right? Okay. Next is nature of trioxides. Boron is acidic, very important, very, very important, students. Boron is acidic, from acidic basic, from each group is also asked to you, right? Okay, surely. Okay, Saravati, I'll take care of that, don't worry, right? Boron is acidic, aluminium and gallium are amphoteric, indium and thallium are basic in nature, down the group basicity increases, right? Okay. Now, let us see important points here. Gallium is unusually low melting point and could exist in liquid state during summer. In high boiling point, makes it a useful material for measuring high temperature. Okay, so it has a very high boiling point and it has a very unusual low melting point. So that is why gallium is used in measuring the high temperatures, right? Because it will not, it is already in the liquid state, but it will not boil very easily. That's why we are able to measure the high temperature. It's a very, very important line from your NCERT. Next is, due to small size of boron, this question is also asked in your PYQ only. Due to small size of boron, the sum of its first 3 ionization enthalpy is very high. This prevents it from +3 ions, forces it to form only covalent bonds. 3-4 questions we can make out of this paragraph. First is, why boron only forms covalent compounds, right? In the options there will be, it has a very small size, it has very, its first 3, the sum of first 3 ionization enthalpies is very high. Third option will be both A and B is the correct answer. Fourth will be none of these. Answer will be A and B is the correct answer. This was your PYQ directly from your NCERT lines. Okay. So second question, what they can ask you, same. Why boron cannot form +3 ions? Reason is same, because of its small size and its sum of the 3 ionization enthalpy is very, very high. That is the reason. Okay, students. Next we have the nature of these oxides. All these are from your NCERT only. I know right now you don't have enough time to go through NCERT. I understand your pain. That is why this lecture is for you, right? Okay. And after this, even if I take big marathons, I'm not going to take this thing again. Trust me on that. I can teach you exceptions again, definitely. When we'll do marathons, I'll teach you what you need to do in the last part of your revision, that is exceptions, because I know that is the cramming part that I'll try to teach you again. But this detailed thing I won't be able to teach you because we just have 20 days. Okay, so now focus here. The nature of these oxides varies down the group. Okay, boron trioxide is acidic. This we have done, forming metal. The gallium oxides are aluminium and gallium are amphoteric. Those of indium and thallium are basic in their properties. This we have done. Okay, this also is very important when they talk about the when they talk about the oxides, acidity and basicity. Now you have carbon family, right? Okay, carbon family. These are the important trends of carbon family. Atomic radii, it decreases. Kaase gaye sun prabhu, it increases down the group. Ionization enthalpy, it will decrease down the group. But in ionization enthalpy, you will see one irregular thing here. That is lead and tin. They will be opposite. That is why this is an important trend for you that they can ask you directly in the exam, right? Okay. Then electronegativity down the group, if you see, it is decreasing only. This question was asked in 2024 JEE question, right? That means in NEET they can repeat that. That means in NEET they can repeat that. Okay, understood? Means questions are repeated, right? So here electronegativity is, we know that here carbon, then you have lead, then silicon, germanium and tin has almost equal, that is 1.6. And Google will give you a different answer here, but you have to follow NCERT only. So this is from NCERT only. If you see the electronegativity trend here, this is 2.5 for carbon, then you have 1.9 for lead, then it is 1.8, 1.8 for silicon, germanium and tin. That is why you should remember the trend from the NCERT, that is this trend. Okay, next, oxidation state. So general oxidation state, okay, tell me the electronic configuration, that is NS2, NP, this is group number 14, na? So this is NP2, right? Total S and P electrons are 4, so it is +4 is the higher oxidation state. Only P electrons are 2, so lower oxidation state is 2. Lower oxidation state stability will increase down the group, that is why +2 state increases down the group. Metallic character is what? Metallic character down the group, it is definitely going to increase, right? Okay. Then melting point decreases up to 10, then start increases, right? Ka, si, gaye, sant. Till there it is decreasing. Then after tin and lead it is increasing. Okay. Then boiling point it is decreasing and density also it is increasing. So here you have the exception. So I'll just mark it here that here you have the exception. Ma'am, please teach me where is that exception. Can you show me that exception? Yes. Okay. So you have melting point. It is decreasing, decreasing, decreasing. Then slightly it is increasing. Decreasing, decreasing, decreasing. Then slightly it is increasing. That marks for the exception. Right? Okay. Yes, everybody. Next is properties from the chemical properties. Right? So first is reactivity with the air. Right? So with the air, what we will do here? Reacts with air to form monoxides and dioxides, CO, CO2, SiO, SiO2, these are formed. Now with air, I also want to tell you, wait a minute, let me see here. This is what you need to learn here, right? All members when heated in oxygen form oxides. Okay, this is what we reactivity with air. Yeah? There are mainly two types of oxide. One is monoxide, other is dioxide of the formula this and this. Now these are some of the important points that I'm going to write now. That is, SiO only exists at high temperature. Important. Oxides in higher oxidation state of elements are more acidic. This we know that more the oxidation state, more is the acidity than the lower oxidation state. The dioxides, all these are acidic, right? Whereas for tin and lead, the dioxides are amphoteric in nature, right? Okay, they are acidic. These are tin and lead, they are amphoteric in nature. If you talk about the monoxides, in the monoxides, CO is neutral, GeO is distinctly acidic, whereas tin and lead are amphoteric in nature. Okay, these are your important oxides, which is amphoteric, which is acidic in nature. Okay, it's a very, very, very important paragraph, right? And this is also a very, very important line, that SiO only exists at high temperatures, right? Okay, now let us do other things here. That is, this we have seen. Reactivity with water, only tin reacts with steam. Rest all do not react with water in any form. What we are saying, only tin. Very important line from here also. These are the exceptions. We usually see only the exceptions of, ma'am, only trends. No, they ask you question from theory part also. Only tin reacts with steam. Rest all do not react with water at all, right? Then reactivity with halogens, reacts with halogens to form dihalides and tetrahalides. Halogens you can see here as well, right? The center metal atom in these halides undergo sp3 hybridization. It will form the molecule is tetrahedral. Exceptions are this, which are ionic in nature. Whenever you see exception, mark it important, right? So they are sp3 hybridization. They are covalent bonded. The tetrahalides are covalent bonded. The exception are tin fluoride and lead fluoride are ionic in nature. Very, very important. Next line is also very important here. That is, PbI4 does not exist because assertion reasoning question. Mark it here, assertion reasoning question. This is the paragraph of your NCRT. Paragraph of your NCRT, right? So here, see this. What we have here is PbI4 does not exist. Why? Firstly, PbI4 does not exist. Why? Because PbI bond down the group initially formed during the reaction does not release enough energy to impair 6s2 electrons, the inner core electrons, and excite one of them to higher orbital to have 4 unpaired electrons around the lead atoms. That is why PbI4 does not exist. Reason is that it does not release enough energy, right? So whenever a molecule is formed, energy is released. That is why molecule is formed. It does not release enough energy to impair 6s2 electrons here. That is why this molecule is not formed only. This does not exist only, right? Very important line. Very, very important, right? Understood? Yes, everybody. Any problem here? Any problem here? Now, next is catenation. From here, I don't think so. They will ask you the question, right? But still go through this. That catenation property, it will decrease down the group, right? Okay. Catenation is self-linking property. Carbon form bonds with carbon, silicon with silicon. That is how you have graphite and diamond structure because of the catenation property. Buckminster fullerene is because of the catenation property of carbon, right? It has the maximum catenation tendency, right? Okay. Next we have regarding the atomic radius. This we have done already. This we have done, students. This we have done already, right? This we have already done. Why this is so poor shielding effect of D of F? So many times repeated, right? Just remember that Kasi Gai San Prabhu, the order is similar here. For ionization enthalpy, the order is changed to lead and tin. They are replaced by each other again because of the same reasons, right? Next we have electronegativity. This also we have, I think, done only. Yes, we have done all of these, right? All of these we have done. I'll just delete it only because what's the point of having extra pages when you have done these things, right? Chemical properties. Since the sum of first 4 ionization enthalpy is very high, plus for oxidation state are generally covalent in nature, right? So whenever you have the sum of ionization enthalpy is very high, in that case it is covalent in nature. That is why CH4, SiF4, all these are covalent in nature, right? But exception we have seen, right? Okay, this exception we have seen already, right? This thing beta we have done already. PB does not exist. This we have done. Okay. I think by mistake it is repeated. Right? Okay. Now let us see next group, that is nitrogens. Nitrogens. Ma'am, why these names are important for you? Yes, these names are important, right? They have asked question. If you don't know, they will ask you electronic configuration. This belongs to which group? They will not give oxygen family, nitrogen family. They will give nitrogens, all these cases, all these things. Okay. Yes, everybody. Increase the volume. Is the voice low? Everybody, let me know in the comment section if the voice is low. If the voice is low, you can let me know it in the comment section here. Right? I'll just change it here. Right? Wait a minute. I'll just change it. This is what I asked you in the starting, na? You tell me if there is any issue in the voice. Wait a minute. Hello, hello. Let me know if now that is audible to you. Right? Hello, hello. Now is that better? Everyone, let me know if now it is better. Right? Now is it better? If that is not better, you can still let me know. I can fix it. Should I increase more? Should I increase more? Then let me know if I should increase more volume. That is why I asked you in the starting, students, that if there is any problem, right? Hello, I think now it's better, right? Okay, now let us see. Now fine, ma'am. Great. Why have not you told me, ma'am, we don't want to disturb you. That's why we didn't told you. And you should have told me these things before the lecture only, before like when I started, right? So now I hope so the voice was not very low, right? The voice was not very low, na? You were easily able to understand what I was saying, right? That was not the issue, right? Fine, ma'am, continue. Yes. Group number 15, that is nitrogen. So here also what we are going to do, first thing is these are non-metals and metalloids, and down those they have metals. These are the radioactive. So atomic radii, ionic radii is simple, it is increases down the group. There is no exception here. Ionization enthalpy, that is decreases down the group, no exception. Electronegativity also decreases down the group. There is no tension in that, right? So if you see this here from this table, right, some of the important points we have here. First is all the elements of this group are polyatomic in nature, right? All will be polyatomic. Dinitrogen is diatomic gas, while all other are solids here, right? Dinitrogen is only the gas, all other like P4, S8, all these are solids. Okay, all these are solids here, right? Now the boiling point increases from top to bottom. From top to bottom, boiling point increases, right? Melting point, very important exception it is. Melting point increases up to arsenic and then decreases up to bismuth, right? Firstly, it increases, firstly it increases up to arsenic, then it decreases up to bismuth, right? Except nitrogen, all elements are show allotropy. Nitrogen will not show any allotropy. Other allotropic means like phosphorus exists in allotropic forms, red phosphorus, white phosphorus. These are the allotropic forms. But nitrogen does not show any allotropy, right? Metallic character is also simple, that increases down the group, right? Okay. So here, this is one of the exception. This was the exception here. This was the exception here, right? Okay, that was the different points, right? Next we have is, let us see, in nitrogen and oxygen, the questions are more asked from hydrides, okay? The questions are asked from hydrides of these elements. So for hydrides, just remember one thing, this thermal stability decreases because down the group the stability is decreasing. It is very easy, you can say basicity also decreases, right? I'll just write it here. First, I'm going to write all the things that are going to decrease. Basicity also decreases, right? As you can see, basic character also decreases. Why I'm telling you, because directly they ask you, what is the trend of hydrides? Thermal stability, basic character, here reducing is increases. So acidity also increases, right? And acidity you have, basicity you have here, reducing bond dissociation. Wait a minute. Down the group, we know that size is, stability is decreasing. So this is maximum stable. So it will need maximum bond dissociation energy. So bond dissociation energy also decreases down the group. So these are the general things that you should remember here, right? These are the general things that you should remember here. Boiling point, I am not telling you why, because boiling and melting point are important. Here you will see one exception. That is why I am not telling you boiling point directly here, right? There is exception in case of NH3 because of the hydrogen bonding. So for boiling point and melting point, wait for a minute. But remember, thermal stability, basicity, bond dissociation energy, that decreases, right? Reducing character, acidity, that increases down the group. Reason is because of increasing size, which weaker the bonds. We know that down the group size increases, bond will weak. It is easy to donate H positive ions. That is why acidity is more down the group. Thermal stability is less down the group. Bond dissociation, to break the bond, it is easy down the group, right? If acidity increases, basicity decreases, right? That is the order. Now let us see the boiling point. Now, because see what should happen here, down the group the boiling point should increase. Down the group the boiling point should increase. But NH3 has hydrogen bonding. That is the reason, it is because it is hydrogen bonded with each other. So its boiling point should be the lowest. But now it is in between. Reason being because it has increased the strength of the bonds by hydrogen bonding. That is why you have NH3 in between here, right? Okay, that is exception is due to hydrogen bonding. That is a very, very important thing, right? Okay, this we have seen here. This we have seen here, right? Okay, then that we have not seen, I think so. No, we have not seen this, right? Okay, reactivity towards oxygen. All the elements form two types of oxides, that is E3, E2O3 and E2O. The oxides in higher oxidation state are definitely more acidic. This is a general thing, right? The acidic character decreases down the group. That also we know because non-metallic character decreases. Important point is the oxides of E2 of nitrogen and phosphorus are purely acidic, right? That means N2O, T2O. These are purely acidic in nature, right? That of arsenic and antimony are amphoteric in nature, right? And that of bismuth is predominantly basic in nature. Okay, understood? So this is the important part. This is the general thing only. Okay, understood? Next is regarding atomic radii. If you see, right? So here only a small increase is observed. This is due to presence of complete. So what you will see in the table, I'll show you that, right? What is the increment here? Where is the table? So size, if you see, this is the radius. Yes, this is the radius. So now what you will see, it is increasing, it is increasing, it is increasing, it is increasing. But you will see here the increase is very large. Here also in the increase is almost large. But here you will see that from this to this the increase is not very high. Right? This is what they are telling you because of the poor shielding effect of 4f electrons. That is not very important for you, but you can go through that. Right? Okay. This is due to the presence of completely filled heavier orbitals elements that you can go through. Next is electronegativity. Right? It is decreasing down the group. Right? And down the group it almost will become similar. Right? Melting point first increases from nitrogen to arsenic and then decreases from antimony to bismuth, right? So this is the order of the melting point. That is very, 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 very important. This we have also seen in the exception flowchart that I have shown you here. That is, melting point increases up to arsenic, then decreases, right? So here also the same thing is written here, that melting point firstly increases from nitrogen to arsenic, then decreases from antimony to bismuth. Hence, this is the order of the melting point for the nitrogen atom, right? For the nitrogen family. Physical properties are, this also we have seen, the boiling points in general increase, but the melting point, this also we have seen, except nitrogen, all elements show allotropy, right? In case of nitrogen, the oxidation state from +1 to +4 trend. Now let us see this thing here, right? This is new to us, right? I'll just delete these pages because that is a repetition only, right? Okay, yes. Now let us see the chemical properties here. In case of nitrogen, all oxidation state from +1 to +4 tend to disproportionate in the acidic solution, right? So here, what is the oxidation state here? This is +1 plus x minus 4. So x is equals to +3. So it is +3. So it will dissociate into 1 plus x minus 6. That is x is equals to +5, right? And here it is x minus 2, x is equals to +2. So it is increasing and decreasing. So when you have oxidation state +1 plus, not +1, between oxidation state from +1 to +4, disproportionate in the acidic solution. This is what we have, right? But in case of phosphorus, nearly all intermediate oxidation state disproportionate into +5 and +3. Like all. In nitrogen, there is specific states. But in this case, nearly all the oxidation state will disproportionate, both in alkali and the acidic. It does not even need acidic medium. It is okay with alkali medium also, right? So that is the important part for you, right? However, +3 oxidation state in case of arsenic, antimony, bismuth becomes increasingly stable with respect to disproportionation. That is why in other cases, disproportionation does not happen, right? Okay. Next is hydrides. We have seen this, right? Hydrides we have done already, right? We have done this. We have done regarding hydrides, right? Okay. All the trihalides of these elements except those of nitrogen are stable, right? In case of nitrogen, NF3 is known to be, only NF3 is known to be stable, right? We are saying all the trihalides except for nitrogen are stable. You can have trihalides here, but it should not have nitrogen. But for nitrogen, only NF3 is stable. All the other trihalides are not at all stable. Okay? Understood? Yes, everybody. Now you have group number 16. Group number 16. Right? N2O is oxide, but we have seen N2O is the neutral oxide, ma'am. Yes. Then what I am saying? Have I done any contradiction here? Weak single bonds. Okay, this one I skipped, no? This one I skipped, I think. Yes. Wait a minute. NN bond is weaker than single PP bond. Right? Very important. NN bond is weaker than, this is very, very important question. That if you see, let me just show you that. This question was asked in JEE Mains, this attempt only. You're saying, ma'am, why again and again you're talking about JEE Mains, JEE Mains, JEE Mains? Because the agency is same here, right? Agency is same. NT is going to conduct that exam in within the gap of 15 to 20 days, right? Okay. So here see this, that means that this topic is very important for you. NN bond is weaker than single. So basically what happens? We know that this is NN, this is PP. Down the group, the bond strength should increase, right? Okay. Sorry, the bond strength should decrease because as length is increasing, the bond strength should decrease, right? This is NN. Here also you have OO and SS. Here also you have FF and ClCl, fluorine, fluorine. Here also you have CC and SI. Now see this, I am telling you for all these cases, right? Okay, all these cases. In this case, it is true that it is increasing. It is decreasing because down the group size is increasing, length will increase. Hence, if you say one length is this is one length, right? This is the one length, this is the smaller length of carbon, this is the length of silicon. So it is very difficult to break this because the bond is stronger. Shorter the bond, stronger the bond. Length is greater, so bond strength will be less, right? But ma'am, that should be applicable here also. But in this case, it is not true. Reason is, here you will have one lone pair. Here you will have two lone pair. Here you will have three lone pair. That is why there will be repulsion. Okay. Because of that repulsion, right? Okay. Wait a minute. N2 was written as amphoteric beta. Wait, let me just see that. After completing, I'll see what is that, what I have done. Right? So this is NN, this OO, this FF. This will be opposite here. It will be this thing. Why? Because these have lone pairs, and that is why there will be electronic repulsions. Electronic repulsions, and because of those electronic repulsions, if the strength of this NN, O and FF is going to decrease as compared to the corresponding next element here. Is that thing clear to everybody or not? Is that thing clear to everybody or not? Right? Okay, I'll just see. If tell me just this thing is clear to all of you or not, where I have written. Beta, here I have written purely acidic type of this nitrogen and phosphorus are the oxides of E2O the oxides of the type, because N2 is a neutral only. I think then maybe some printing mistake or something, but N2 is neutral only, right? Okay. Wait a minute. E2O3, the oxides of this. This is neutral only, students. This is neutral only. Very good. I am very smart, huh? Very, very smart. Right? Predicted it right. So this you can cancel this here. Right? They may be talking about E2O3, I think. Right? Basically, this is a line of NCRT only. It should not be wrong. But N2O oxide is definitely a neutral oxide zone. Oxide only. Let me just see this also. I don't want to mislead you in any form. It is a neutral oxide only, right? Wait a minute, let me see this line. E2O of nitrogen, phosphorus are purely acidic. Because these two lines are contradicting. Maybe some typing mistakes. Thank you. Who was there to identify this mistake? There should be E2O3. E2O3. Very good. Very good, very good, very good. Because N2 oxide is, we have seen that it is neutral oxide only. Right? CO, N2O, NO, all these are neutral oxides only. Okay, very good, huh? Aditya, very good. Shabash. I'm very proud of you on this. Right? Excellent. Because you have, I'll just ask the team to correct it here. Right? Because I also took it from NCRT only, but I think by mistake, some printing mistake was there. Okay. So now we have done this as well. We were at this point where we were at this point. Okay, this also we have done. Now let us start with the group 16 elements. Okay, let us start group 16 elements. Let us start that. Okay, no, N2 was never amphoteric. Where it was written amphoteric? N2 is neutral only. Where it was written amphoteric? Arey yaar, I have to see all the slides now. Just let me see where it was written amphoteric. This is not nitrogen. This is not nitrogen. Nitrogen. Okay. Okay. Here also it is not written. 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 But nowhere it is written that it is amphoteric. Okay. Okay. Yes. Now let us start with the group number 16. Yes. Now let us start with the group number 16. If that is chemical properties, firstly we will start with, right? So chemical properties are that in this case minus C, you have NH2, NP4. So plus 6 and plus 4 are the oxidation state, and minus 2 is also one of the very stable oxidation state because it is electronegative in nature. Minus 2 oxidation state decreases down the group. Why? Because minus 2 means to take out the electron, to gain the electron itself. So its electronegativity is decreasing down the group. That is why minus 2 state is also decreasing down the group. Next is the tendency or the stability of plus 4 oxidation state in comparison to plus 4 plus 6. We know that lower oxidation state will increase down the group, right? Okay. Next we have is the properties here. These are the properties of hydrides for you, right? Okay. So let us firstly see the properties of hydrides. Okay. So properties of hydrides are very similar to that what we have done before also. Thermal stability decreases down the group, or you can say basicity decreases down the group, or you can say bond dissociation energy decreases down the group, right? But if I want to talk about reducing character or acidity, that increases down the group, okay? That increases down the group, right? Okay. Except for H2, right? Except for H2, right? Down the group, thermal stability decreases. Right? This you should not write it here, right? Okay. Now next is boiling point, very, very important. Now why this is so important? Because H2O also has hydrogen bonding. That is why we know that NH3 was on the third position. We know that boiling point should increase down the group, right? It should also increase down the group. But H2O should have the lowest boiling point then, but it is on the last position. Similarly, in hydrides of nitrogen also, NH3 should have the least, but that is on the third position. This is on the last position because here hydrogen bonding is even stronger, right? It is even stronger, right? Then acidic strength we have already seen. Now, let us see some of the important points regarding the chemical properties, right? All these elements of oxides, EO2, E2 type oxides, right? Ozone is there, sulfur dioxide is there, selenium dioxide, all are solid here, right? If you see selenium dioxide are solid, SO2 is gas, we all know, O3 is also gas, we all know. Reducing property of dioxide decreases from sulfur to beryllium. SO2 is reducing. Now, this is very, very important. This question was asked in your PYQs. SO2 is reducing while TeO is oxidizing agent. SO2 is reducing while TeO2 is oxidizing agent, right? Because down the group, what exactly happens? Okay, so here it has +2 oxidation state. Here also it has +2 oxidation state, right? Okay, so that is why we know that lower oxidation state is stable down the group, right? Okay, so that is why here, if you see, this is also SO2, this is also this, down the group, the acidic character, right? Non-metallic character decreases. So that is why the acidic character of this also decreases. Hence the TeO2, which wants to be oxidizing agent, that means it wants to reduce something, it wants to oxidize something, it wants to itself get reduced, it wants to get converted to, if you see, here it should be +4. Wait a minute. That is the mistake. Here it should be +4 oxidation state. Here also it is +4 oxidation state. X minus 4 is equals to 0. So down the group, what you will see, down the group, we know that lower oxidation state increases, right? So this wants to get reduced to plus 2. Its tendency to get reduced to plus 2 is more as compared to selenium. Reason is why its tendency is more as compared to sulfur. Reason is in the down the group lower oxidation state increases. So it wants to be in a plus 2 oxidation state. Okay. Next is besides EO2 type, sulfur and selenium. This is a very, very important point. Okay. SO2 is a reducing agent while TiO2 is an oxidizing agent. This is very, very important. Very, very important. Directly one question can be asked here. Besides this, sulfur, selenium, beryllium also form EO3 kind of oxides, right? Okay, now let us see sulfur, selenium, beryllium, all these have acidic oxides in nature, right? Okay, now let us talk about electron gain enthalpy. That is one of the exceptions and a very, very important exception of or oxygen compounds. Okay, very, very important. Oh, peak quality for NEET. Yes, thank you. Now let us see this here. Electron gain enthalpy. If you see this, down the group, electron gain enthalpy should decrease, right? So, ma'am, the trend should be oxygen, sulfur, selenium, usse TePo, right? Okay, this should be there. But oxygen being the smallest, it has the smallest size. So it's like I don't have room for electrons, right? So that is why I'm not able to accept any electron. Hence, what you will see, sulfur, selenium, then you have beryllium, then polonium, then in the end you will have oxygen here. That is the exceptional trend here because of the small size of oxygen here, right? That is because of the small size of oxygen here, right? Understood? Then ionization enthalpy follows the general trend only. This we have seen. This is due to that we have seen already. It follows the general trend only that I have told you in periodic classification as well. Right? Hydrides trend also we have seen. Next is reactivity towards halogens. Almost hexahalides, hexafluorides are only stable halides. Very important that hexahalides, hexafluorides are the only stable halides. That means only hexafluorides exist, right? Other halides does not exist in hexa form, right? Sulfur hexafluoride is exceptionally stable for its steric reason. This so you have seen also. SF6 has this kind of molecule. It is exceptionally stable due to its steric reasons. Okay? They can ask you some question regarding in a mixture of chemical bonding and this SF6. The compound, draw the structure of the compound that belongs to group number 16, which is exceptionally stable in its hexa form. So that will be SF6. Okay. Now, next is all element except oxygen form dichlorides and dibromides, right? So if you see the dihalides formed by sp3 hybridization have tetrahedral structure. The well-known monohalides are dimeric in nature. Examples are these are dimeric in nature. The dimeric halides undergo disproportionation as given below, right? So basically monohalides also exist in a dimer form, right? Okay. Then we have properties of halogens. Okay, then we have properties of halogens. Yes, everybody, properties of halogens, very, very important, right? After this, we will start doing the questions. Then your part will, I want to see you guys answering in the comment section. Very good, everybody. Answer is group 17 elements. If you see this here, right? If you see this here, now here atomic and ionic radii increases, that is general. But if you see ionization enthalpy, that decreases, that is also general, right? But electron gain enthalpy, can you see this is the exceptional trend here? Electron gain enthalpy, can you tell me why? Electron gain enthalpy is, it should be fluorine, chlorine, bromine, iodine. Electron gain enthalpy is decreasing down the group. So it should be fluorine, then chlorine, then bromine, then iodine. It should be like this, right? But in reality, what happens, right? Fluorine is shifted to this side. right? You have, let's say it is decreasing, right? So chlorine, then you have fluorine, then you have bromine, then you have iodine. Fluorine shifts to the second position. In oxygen family, oxygen, because of the small size, is shifted to the last position. Reason is it has three. Oxygen has the smallest size, it has two lone pairs. Fluorine also has the smallest size among the periodic table, and it has three lone pairs, too many electronic repulsions, but also it is very electronegative. So they will fight with each other, and in the end, the result will be you will have fluorine, then bromine, then iodine. That is a very important trend. Okay, understood? Electron gain enthalpy is a very important trend. This is a very important trend. Acha, one more trend is very important in this case, that is bond dissociation enthalpy. It should be down the group size is increasing, so bond dissociation enthalpy should be least. So it should be F2, then Cl2, then Br2, then I2. It should be like this. But in reality, we know that FF, because of the electron repulsions, right, the bond is not very strong. So it will not have the maximum bond dissociation enthalpy. Hence, it will go to this place, that is after bromine, you will have fluorine, then you will have iodine here. Right? Very important again. Very important. Right? These two trends from halogens are very important: electron gain enthalpy and bond dissociation enthalpy. Right? Okay. Next is non-metallic character is simple only, that you have non-metallic character decreases down the group. Iodine shown some distinctive metallic characteristics, though it should be very non-metallic, right? But it shows very distinctive metallic properties. It possesses metallic luster, forms positive ions like I positive, I3 positive, right? So that is for iodine, right? Next is the negative. Now we are saying that fluorine has negative electron gain enthalpy, right? The negative electron gain enthalpy of fluorine is less. That means the happiness is less. The happiness is less. It's like you love dosa, you are craving for dosa, but the dosa was not too good. Sometimes you love something, but that was not up to the mark. You didn't like the taste of the person who prepared it, right? Yesterday only I ate spring rolls. I love spring rolls, but yesterday I ate worst spring rolls of my life, right? So I wanted to eat spring rolls. It was raining, but I was very sad after that. Reason, because it was not up to the mark. So fluorine is like, I have too many electrons, right? So if you forcefully give me electron, I will not be happy, right? That is why its electron gain enthalpy, that is the release of energy, is not that much. That is why it has less negative electron gain enthalpy, right, than that of fluorine. It is due to the small size. This we have done because of the electronic repulsion, right? Okay, yes. Now there is physical properties here. One curious phenomenon we noticed from the smaller enthalpy of dissociation. This also we have seen that why this has smaller enthalpy, because of again the electronic repulsions of the lone pair. This also beta we have done. Okay, this also we have done. Right? Now, fluorine oxides, fluorine oxides water. Now this is very important. Now 3 pages, very important pages. Oh, something happened. My bindi shifted here. My bindi shifted somewhere else only. Okay, so now I think we are left with very few trends here. After that, okay, great. Fluorine oxidizes. Now students, see this here. Fluorine oxidizes. We are saying that fluorine, it is going to oxidize water to oxygen. See, fluorine, it is going to, very important, this is a very important page of your NCERT. Fluorine is going to oxidize water to oxygen. Okay, it is going to oxidize water into oxygen, right? Then it is saying, whereas fluorine and bromine react with water to form corresponding halohalides. If you have fluorine and bromine, here, it will form halide and halohalide, right? So it will form hydrohalic and hypohalous acid, HX and HOX, right? HX and HOX. The reaction of iodine, now they are saying fluorine with water, it is going to oxidize into O2. This with water, it is going to form HX and HOX, chlorine and bromine. But iodine is very weird. Iodine is different only. Iodine, what it is going to do, the reaction of iodine with water is non-spontaneous. It does not happen. Forcefully we have to do it. But I negative can be oxidized by oxygen in acidic medium, right? Just the reverse of what we were thinking, right? So fluorine is oxidizing water to O2, but here in case of I negative, in addition of water, it is itself getting converted to I2. Itself it is getting oxidized. It's like in some universe, fluorine is actually giving money. Iodine is taking money, right? So fluorine is like, I'll oxidize water to O2. Iodine is like, I will not oxidize. I2 does not have that power. But you can do the reverse. You can form I2 with the help of I negative, adding it into the water. Got it? Yes. Most of the reactions of fluorine are exothermic in nature. That is why it is very difficult to have that in the compounds. It forms only oxoacids with other halogens, form a number of oxoacids. It only, acha, this is a very, very important question, right? This was your PYQ. Okay, this is your PYQ, very, very important. Due to small and strong bond formed by it, small and strong bond, it forms only one oxoacid while other forms a number of oxoacid. They will ask you, assertion is why fluorine forms only one oxoacid? Because of its small size and very strong bond. It forms only one oxoacid. Is that clear to everybody? Right? Okay. Yes, everyone, if that is clear, then let me know in the comment section. Right? Then we have, let's talk about the hydrogens. They all react with hydrogen to give hydrogen halides, but different affinity for hydrogen. So basically all of them for HF, HCl, HBr, HI, these compounds are formed here, right? So some of the properties of this is given in the table. The acidic strength varies in the order this. This is the acidic strength. Reducing power, you can say. This is because see, down the group we know that size is increasing. So H positive easily can be donated. So that is why acidic strength increases. Stability of this decreases down the group, right? Stability, basic strength, you can say this is the order of stability or basic strength Okay, stability or basic strength that will decrease down the group, right? And also bond association energy. Okay, next is okay, one more thing you can learn from here, that is one more thing, one more important factor. I'll just write it here. Boiling point here is, it should be basically, if you see the boiling point, HF has the maximum, then it is decreasing, then it is increasing, then again it is increasing. So out of this, the maximum boiling point is of HF, then you have HI, then you have HBr, then you have HCl. That is the order of boiling point. Can you tell me how this is the order? See, very simple thing is, down the group we know that boiling point should increase, right? In every halide we were doing the same thing, hydride. Down the group it should increase, right? It should be fluorine, chlorine, bromine, iodine. But HF has the maximum boiling point. Can you tell me what is the reason? Because of the hydrogen bonding. And it forms a very symmetrical structure. That is why its structure is even more symmetrical. That is why it will have the highest boiling point among these, right? So that is why this will become the correct order. Again, this is very important. The boiling points of nitrogen halides, halogen halides and oxygen halides. All these three are very important, right? Okay, understood? Now, noble gases, you don't have as such many exceptions because the compounds are very rare here, right? So here what you will see, general electronic configuration is this, right? Except for helium, that is 1s2. Ionization enthalpy decreases due to stable electronic configuration. They exhibit very high ionization enthalpy. They are like, you can't take away electron from me, right? And they have no tendency to accept the electron. Therefore, they have large positive values of electron gain enthalpy. They're like, I don't want positive value. Electron affinity is very negative. Can you tell me why electron affinity? The tendency, the ability, the want to have to eat food is negative. They don't want to eat food. But when you forcefully give them the food, then they're like, I'm not happy after eating the food. Right? Khichdi, the example of khichdi. Okay? So after food, they are not happy. That is why they will not release energy. They will absorb energy. That is why electron gain enthalpy is positive here. Right? Okay. Understood, students? So this is the trend of electron gain enthalpy, right? That you can see very rarely asked. Never they have asked this, but still I have just written it here for you, right? I have written it here for you. You can go through this, right? Okay. Helium has the lowest boiling point of any known substance. It is unusual property of diffusing through most commonly used laboratory materials such as rubber, glass, and plastic, right? That we usually see in our daily life. We also see helium balloons, all of these things, right? Okay. Along the period, we have already done these things. I think we have already done these. Yes, we have already done these things in the periodic classification. Now, trends we have seen. Okay, trends we have done, right? Okay. Okay. Now, the oxo acids of phosphorus and sulfur, they are extremely important for you. The oxo acids, I have taken the screenshot from NCRT only, right? These are not, these are structures that are mentioned in NCRT because out of NCRT you don't have to do anything, right? So this structure is important, the name is important. H4P2O7 pyrophosphoric acid, orthophosphoric acid, hypophosphoric acid. These are important. These you can still skip. If you want to skip this, you can. But these four you should do, right? Okay, H3PO4, H4P2O7, H3PO3, H3PO2. This, so I have already drawn the structure with you only. This also we have drawn. This also we have drawn. If you remember when we were doing the acidity of oxyacids of phosphorus, I have drawn these three structures for you, right? So here it is H4P2O7. Always remember with phosphorus there will be one double bond O definitely, right? So there is one double bond O with phosphorus, right? Here also it is double bond O. And in this case you have one POP bond also. So POP, rest you are left with 4O and 4OH here. So that is why you will have 4OH here, right? That is pyrophosphoric acids, right? Next we have is oxoacids of sulfur, right? Okay, so all the oxoacids H2SO3, H2SO4, H2S2O8, H2S2O7, right? All are very important. All are very important for you, right? Okay, students, all these acids are very, very important for you, right? The diagrams are very important. Same way you will do. First, you will have a sulfur double bond O. Rest of this will be firstly OH. Then you will be left with one hydrogen or two, right? Mostly in this case, you will not be left with hydrogen here. Here H2SO4. This is the structure. Two double bond O, two OH here. H2S2O8. You have one peroxide linkage SOOS, right? One OH, two double bond O, two double bond O, right? Here you have H2S2O7, one SOS linkage, two double bond O, two double bond O, one OH, one OH. Here you have H2S2O8, H2S2O7. That is why here you have peroxide linkage, here you have simple one oxygen. Okay, clear everybody? Yes, everybody. Okay. Hush. Now we have completed, right? I'm so tired right now, but I now want you guys, because till now you were very silent in the chat, that I can completely understand. When you are studying, definitely you will be silent. But now the silence will kill me, right? Why? Because right now is your task to answer the questions, right? Now we are going to do questions here. Rest of there are questions, too many questions we have here. And I want you guys to do these questions, right? Within a very less time. After that we can do, so that after that we can do the D block as well, right? D and F block as well. Okay. Yes, everybody. Okay, let us do that. Let us do that. Let us do that. Among the following, now this will be a rapid fire round. Now I want all of you to answer this, because explanations already I have given you, right? So let us see this and do this. Among the following, the electron deficient compound is, that is definitely BCl3. Why? Because boron is electron deficient species here, right? Next students we have is, wait a minute, what is there? Okay, yes. The correct order of ionic radii of this. These are isoelectronic species. Isoelectronic species. Isoelectronic species means more the negative charge, more will be the size. More the positive charge, less will be the size. So answer will be A is the correct answer. Again, right? Next question is the correct order of electron gain enthalpy here. Electron gain enthalpy, the correct order in case of oxygen. Oxygen is very small. It does not want to gain the electron. Down the group, the electron gain enthalpy should decrease. But oxygen being the smallest will be like, I don't want to gain the electron. That is why I'll have the least electron gain enthalpy here. That is why answer will be A is the correct answer. That is how smartly you will answer the questions in the exam hall. In general, the properties that show opposite trend in comparison to other properties along the period. Everybody, in general, the properties that shows an opposite trend in comparison to other properties, right? So we know that atomic radius, if it is increasing, rest of the things will decrease. That means that I have told you variation also, it is inversely proportional to rest of the things. The correct order of atomic radii in case of carbon, CS, Al and S. So here very simple thing, carbon, aluminium, sulfur and so here it is from the second, third, and this is from the sixth period. This belongs to the group number 1, right? So if you see this here, right, we know that this is carbon, that is period number 2nd. This is group number 1, right? Group number 1 and 6. That is why it is going to have the largest, because over here the size is maximum and here size is increasing. So CS is going to have maximum, right? Now which is going to have the minimum? If you see aluminium and this, these are in between. But carbon is the second period and it belongs to group number 14. 14 is here, 13 is here. Size of 14 is less as compared to 13. That is why carbon will have less size. So answer will be A is the correct answer here, right? Next we have is, which of the following will represent the correct order of increasing first ionization enthalpy? First ionization enthalpy, right? First ionization enthalpy. Now you have to place all these atoms here. So when you place all these atoms, this is group number 2, calcium, barium, sulfur, selenium, argon, right? What you will see, that is opposite. Argon, we know that it does not want to lose the electron, so it will have the maximum electron ionization enthalpy. After this, we know that along the period, this is group number 16, along the period, if you see, the ionization enthalpy will increase. So 16 is going to have more. Down the group, it decreases, right? So sulfur and selenium is going to have more as compared to this calcium and barium. But out of this, sulfur is going to have more because it is decreasing down the group. So it is sulfur, then you have selenium. Here we know that which is going to have more, calcium is going to have, that is why calcium then barium. So these are the general trends, okay, general trends. The electronegativity of the following elements increases in the order. Again, you have to place these elements in the periodic table, right? So when I'm placing these elements, let's say, this is the carbon, this is silicon, this is nitrogen, this is phosphorus. Okay, so when you place these elements here, they are asking you the electronegativity order here. We know that here it is increasing. So nitrogen and phosphorus are going to have more. So we know that nitrogen is going to have the maximum increasing. Nitrogen is going to have the maximum only in C part. Only in C part nitrogen has the maximum. After that you will have carbon because it is decreasing, right? Then you will pick out this one. Here phosphorus will be more, then you will have silicon, right? That is why C is the correct part. This I have done when I was teaching you periodic classification, right? The electron gain enthalpy of this, electron gain enthalpy. Fluorine does not want to gain the electron. So there is fluorine, right? Then there is fluorine, then there is bromine, then there is iodine, right? Okay. So these are the electron gain enthalpies here, right? Okay. Wait a minute. Electron gain enthalpy decreases down the group, right? Yes. These are the electron gain enthalpy. Chlorine is going to have maximum, right? Okay. Chlorine, you just see the number here. Chlorine should have the maximum, then fluorine, then bromine, then iodine should be there. So part is C, where chlorine has the maximum, then fluorine, then chlorine, then you have the iodine, right? Okay. Understood? So that is the general thing. They have given you this in the form of digits here, right? The enthalpy of group 13 follows which order? Group 13, again that exception 1, 3, 1, 5, 3, 2, 1, 5, 3, 4, 2, right? Okay. So that will be exception we are saying, na? Exception we are saying. So directly you will see that W only here, right? According to that you will answer this. According to that the answer will be, firstly you have boron, then it is decreasing, then again it is increasing, then again it is decreasing, then again it is increasing. Okay? Decreasing, increasing, decreasing, increasing. That is how it is going to do. Okay, so answer will be D is the correct answer. The element which shows least metallic character out of these. So metallic character, metallic, we know that along the period down the group, here metallic character decreases, here metallic character increases, right? So here they are talking about BAlGain, right? Now you tell me out of this which is going to have the least. Down the group it increases. So which is going to have the least? That is boron, because down the group metallic character is increasing. So boron will have the least. Which one of the following has lowest melting point? Melting point. So that I told you in the, everything is there from the paragraph that I taught you. Gallium, right? That is going to have the lowest melting point, right? Okay. Let us see which one of the following element is unable to form. Now, this is a new question that I have not told you in when we were doing theory part. So remember that all the first elements cannot expand the octet, cannot expand covalency. Covalency. So all the, if you're talking about this group here, that is group number 13, boron is the one which cannot expand its octet beyond 3. Right, so because they don't have vacant d orbital, so always first element is going to be the answer for any group there. The stability of +1 oxidation state. +1 oxidation state is the lower oxidation state. It will increase down the group. So just pick the just take out that option where it is increasing down the group. Right, so lower oxidation state should increase down the group by Indian. So it is B is the correct answer. Okay, it should increase down the group, lower oxidation state, right? Next is the correct statement regarding group 13 element oxides. Let us see how many of you are able to answer this. Very few students who are actually answering the questions, right? Students, try to answer it. The correct statement regarding group 13 elements. I am seeing your comments. My one eye is here, one eye is there. Right? So try to answer the questions yourself also. right? I have taught you all of this and still you're not able to answer, then there is no use, right? Try, at least try to answer this. The correct statement, boron trioxide is acidic. Oxides of aluminium, gallium are amphoteric. Oxides of indium, thallium are basic. That is definitely correct. So all these statements are correct here, right? All the statements are correct. That is A is the correct answer here, right? Boron forms covalent compound. Why it forms covalent? Why it forms +3 oxidation state in +3 only? Reason being because of high ionization energy of +3 ionization energy are very high. Then it's small size. So both A and C are the correct answers. So answer will be D is the correct answer. Next is the structure of diborane. Now, this also I have not taught you in the theory, especially I have kept this question for you, right? So, this is the structure of diborane. Here you will see you have 1, 2, 3, 4. 4 terminal BH bonds and 2 bridge banana bonds, okay? So, you will see these are 2 electron 1 centered, okay? So, this is, sorry, 2 electron 2 centered. You have 2 electrons and 2 centered. Here you have 3 electrons and 2 centered. So, 3 electron 2 centered are nothing but bridge bonds, or you can say banana bonds, or you can say banana bonds. Okay, so that you have to remember because this is very important structure. And I told you that important structure I'm not going to miss here, right? Because I don't want you to take risk here. Otherwise, you will curse me in the exam that, ma'am, why we trusted you and still you didn't tell us that you have to do this, right? So I will not do that to you. In diborane, you have 4 bridge hydrogen and 2 terminal, no. You have 2 bridge hydrogen and 4 terminal bonds. That is, B is the correct answer. You have 4 bridge hydrogen and, 4 terminal and 2 bridge hydrogen you have here, right? Okay, so answer will be B is the correct answer. Next is marked oxide, which is amphoteric in nature. Amphoteric oxide, students. Amphoteric oxide. How many of you are able to answer this? Amphoteric oxide. Let us see. I am waiting for answers here. CO2. Is it amphoteric? It is acidic oxide. SiO2. Tin oxide is amphoteric oxide. Aluminium, zinc, vanadium, lead, tin, arsenic. All these are amphoteric oxides. Okay, all these are amphoteric oxides, chromium oxides. Okay, all these are amphoteric oxides. So answer will be C is the correct answer. Right? Next, which of the following is not correctly matched? Okay, which of the following is not correctly matched? So you have to see this. GeO2, PbO2 amphoteric, SiO2 and GeO2. What about these two? See, second and third are definitely correctly matched here. You have to see between germanium and silicon. Yes, everybody. So here we have fourth, that is your acidic oxide. Then you have G is your that is your acidic oxide. It should be na, yes. Okay, so the dioxide, CO2, SiO2, these are acidic in nature, right? That I have told you there. Tin and lead are amphoteric in nature, right? Okay, so these are important. Okay, yes, everybody. Next we have is which of the following halides? Which of the following halides is most stable? Most stable halide. Most stable. In fluorine, the halide is very, very stable, right? So answer will be CF4, right? The thermal stability of the halides usually are existing in if you have different elements. So it decreases down the group. But if you have the same metal, then fluorine halide is the most stable, right? Most stable, out of which sulfur SF6 is maximum stable, exceptionally stable. The elements that does not show catenation among them, carbon, silicon, germanium will show, lead will not show any catenation property, any self-linking property. See, if you know the answer within seconds, you can solve in organic chemistry, right? Which of the following is incorrect statement? You have hydrolyzation, basically they are asking you. This is easily hydrolyzed. This is covalent in nature. This is more stable than this. S and F4 is ionic in nature. You have to tell which of the following is incorrect statement here. Incorrect statement, everybody. Which of the following is incorrect statement? So here if you see PbF4, that we have already told you, PbF4 is ionic in nature due to high electronegativity. If you remember this, I have told you this in the paragraph form also, that PbF4 is ionic in nature. Especially I have marked it there, that PbF4 will be ionic in nature. Okay, then which of the following is not stable here? Not stable. Not stable. So you'll say, ma'am, how can I answer this question? Right? So these are the questions that you can only, they don't need any theory. You don't need any theory for this. You need logic for this. Right? So in this case, see silicon, right? Silicon is not a very big atom. If you talk about germanium and tin, silicon is the smallest. Silicon can only accommodate some smaller atoms like fluorine. It cannot accommodate big atoms like fluorine here. That is why this is not at all stable, because fluorine is a bigger atom across the, so silicon will not be able to accommodate fluorine around it, right? The reducing power of divalent species decreases in the order. Divalent species, reducing power, right? Reducing power of divalent species. If you see +2 and +4, +2 oxidation state is stable down the group. Stable down the group. So if you see G, so it is stable down the group. That is why this germanium would want to reduce. Reducing power means to reduce someone itself get oxidized. This can get converted to +4 oxidation state easily, because higher group elements are more happy with higher oxidation state. So answer will be A is the correct answer. Okay, because Ge2 positive, we know that it is not very stable here, right? So it would want to get converted to +4. But down the group, +2 is very stable. So that is why it would not want to get converted to +4. Oxidizing power means it is itself getting oxidizing power means it is itself getting oxidizing power or reducing power. It was reducing power, right? So that means itself it is getting oxidized. It wants to increase the oxidation number. So that is not possible, right? Okay. It is because of inability of Ns2 electrons of the valence shell to participate in bonding. Very important question, again based on that thing, that this is oxidizing, this is reducing. So we know that Sant Prabhu, this is more stable. See, Pb is more stable in +2 oxidation state. Sn is more stable in +4 oxidation state as compared to Pb. Right, because down the group oxidation, lower oxidation state increases. Say based on just one concept, that down the group lower oxidation state increases, we have seen two questions, okay, based on one simple concept, right? So here we know that, so they are saying this is oxidizing, that means it would itself want to get reduced. That is not possible, right? It would itself want to get oxidized. That is why it is a good reducing agent, right? So, and that too not SN4 positive. SN2 positive is a very good reducing agent, right? Because it would want to get converted to +4 oxidation state. And this would want to get converted to +2 oxidation state. If it is oxidation number is increasing, it is getting oxidized, it is reducing something. Oxidation number is decreasing, it is getting reduced, it is oxidizing something. So Pb4 positive is a good oxidizing agent. That is how you're going to answer these questions, okay? Don't cram anything. That is why I explained it. I was not explaining you the trends, because that we have seen already. These questions are the application of the concepts, okay? Next is the 3 important oxidation state of phosphorus. See, phosphorus is NH2NP3. So it will be 3 + 2, that is +5 oxidation state, right? Then you have p electrons, means only p electrons means 3. First you add both the electrons, that is 5. Then you only take p electrons, that is 3. Now we know that nitrogen family is also electron negative in nature. So it can also lose the 3 electron, right? Okay. It can also, sorry, gain 3 electrons because it is very electron negative and become P6. So that is why -3 is also very stable here, right? Which of the following has highest p pi p pi? Now always remember, any group given, any group, p pi will be in the first element. P pi will be in the first element because rest of the elements has d orbital, right? That is why there will be d pi p pi bonding. That is why rest of the elements can expand their covalency, right? So here you will have nitrogen will have highest p pi bonding here, right? Which has lowest boiling point? Lowest boiling point, we know that down the group boiling point is increasing, right? That means then nitrogen will have lowest? No, no. Phosphorus will have lowest because nitrogen, because of its hydrogen bonding, will switch to the third position. Will switch to the third position like this. Okay. Firstly P, then AS, then you have NH3 because of the hydrogen bonding. So answer will be B is the correct answer. Okay. Next, most acidic oxide among the following. Okay. If they ask you the acidic oxides, what you have to do? Oxidation number. Calculate the oxidation number out of this, right? So what you will see, this, see, definitely one simple thing. Okay. First you have nitrogen, then you have phosphorus, then you have arsenic. We know that down the group, what is happening? Metallic character is increasing, right? So that means acidic character is decreasing. Nitrogen, then phosphorus, then arsenic. That means our option is either this or this. Ma'am, now out of these two, how you will calculate? More the number of oxygens, more is the acidic strength. Or you can also calculate the oxidation number, but the trick is more the number of oxygen, more is the acidic strength. So here, more oxygen means more acidic strength. Got it? How you're going to answer it? The correct decreasing order of basic strength here of hydrides. Basic strength. Basic strength. Everybody, it increases or decreases in any of the hydrides. Thermal stability, it decreases here. So answer is going to be, it is the correct answer. It is decreasing down the thermal stability, basicity, bond association energy, they all decreases. Stability, bond association energy also decreases down the group. Okay. Acidity reducing power increases down the group. Which of the following fluorides does not exist? Now let me see how many of you can answer this. Which of the following fluorides does not exist? NF5, right? Nitrogen can never have pentavalency, not possible for nitrogen. It is like I am happy with maximum 4, I can make that too with a positive charge. It cannot expand its valency, right? Which of the following oxoacids of phosphorus has strongest reducing property? In this case, there is exception. More the number of hydrogens, reducing property means acidic strength. You will say, ma'am, this has maximum number of oxygen, more the number of oxygen, more is the property. No, you will see the hydrogens here. So if you see the hydrogens, hydrogen will be maximum in this case. Let us see how. So here, that's why I told you to do these, at least these 4 oxyacids of phosphorus, okay? So here you have maximum hydrogens in case of H3PO2. That is the reason this has the maximum acidity, maximum reducing power, right? Okay. Oxidation state of P in this. Oxidation state you can easily calculate. I'll calculate for any of them. Let's calculate it for this one. So it is 4 plus 2x minus 6 is equals to 0. So 2x is equals to, there is also one peroxide bond here that you should remember. Here you have a peroxide bond. Okay. You should remember if there is a peroxide bond or not, right? According to that only you will answer. Minus 6 is equals to 0, 2x is equals to 2, x is equals to this. Okay? This is 12. 6 to 12 is equals to 0. 2x is equals to 8, x is equals to 4. Right? Okay. So here, what you should remember is that if there is any peroxide bond here, here you have no peroxide bond, this will show you minus only. If you don't have any peroxide bond in the compound, then you can't calculate the oxidation number directly, because for every oxygen of peroxide, there will be -1 charge. But if you don't have a peroxide bond, then each oxygen is going to have -2 charge. So directly you can calculate from that. But if it has a peroxide linkage, then things will change. Okay. Number of POP bonds in cyclic metaphosphoric acid. Cyclic metaphosphoric acid, if you see, this is the cyclic, this is number of POP. 1, 2, and 3. So 3 POP bonds are there, right? Okay. I don't think so they will ask you this kind of question, but I feel they will, the 4 phosphorus oxyacids that I marked, I feel that they will ask you. But if you can remember all the oxyphosphorus acid and oxysulfur acids, right? Okay. Or no other structure I am asking you to do. Arrange the following elements in the correct order of increasing radii. Okay. Increasing radii, that is the simple order only. So directly it is increasing down the group. There is no irregularity here. Which is the correct thermal stability of H2E in case of this? Thermal stability is again decreasing down the group. So it is decreasing down the group. So directly you can say, wait a minute, decreasing down the group. Na? That was not decreasing. Kya? Decreasing. That is also decreasing. Na? Wait a minute. It is decreasing. Achha, that is increasing. So sorry. Yes. So sorry. I thought that is decreasing. Yes. That is decreasing, right? This is decreasing. I think after 3 hours, na, my brain little bit rest it needs. Which of the following hydrides has lowest boiling point? Lowest boiling point. I think this question is getting repeated, or is it? This question, is it getting repeated, students? Is the questions getting repeated? Don't worry, we have very few questions left here, right? Very few questions left here, right? Okay. So lowest boiling point they ask you, we know that H2O will not have, rather H2S will have. This has the hydrogen bond. Okay, it is not repeating. We did the same question for nitrogen, right? So H2S will have here, right? Because H2O will be in the end. H2O will be in the end. Boiling point increases down the group. Increases down the group. But H2O, because of hydrogen bonding, it will be in the end. So answer will be B is the correct answer. Very good. Which of the following oxoacid of sulfur have peroxide linkage? So this also I told you, you should remember those 4 oxoacids of sulfur. So which has peroxide linkage? Peroxydisulfuric acid. When 2 sulfuric acids, when they lose water, when they combine together, you have 1 sulfuric acid. 2 sulfuric acid, they will combine together. Let's say you have one more sulfur here. Let's say this is OH and this is double bond O, and this is S double bond O, this is double bond O, this is OH and this is OH. Now you take out water from here and this is linked. That is nothing but that is peroxosulfuric acid, right? Okay. Acha, if you lose water, that is your pyrosulfuric acid. Acha, this is your pyrosulfuric acid. This is peroxo. When you make pyrosulfuric acid, just add one more oxygen here. That is your peroxosulfuric acid. That has peroxide linkage. Okay. Next we have is electron gain enthalpy with negative of fluorine is less than that of fluorine is due to, because of the small size of the fluorine, right? It has lone pairs on it. So fluorine is not able to accommodate the electrons. That is why it's not possible to have electron here, more electrons. The correct order of increasing oxidizing power. Oxidizing power. Fluorine has the maximum oxidizing power if you see even in the table, right? So fluorine has the maximum oxidizing power. So answer will be D. It is decreasing down the group. Even in electrochemical series, those who have no idea about this, from electrochemical series also you can answer that how fluorine has the maximum oxidizing power. In case of alkali metals, the covalent character decreases down the group. Covalent character down the group, acha, they are saying the covalent character decreases in the order. Okay, increases in the order. Covalent character means you have to apply Pajan's rule here. So what you will see, the difference is in the, if you see fluorine, chlorine, bromine, iodine. Fluorine minimum, then you have chlorine, then you have bromine, then you have iodine, which has the maximum size, right? Down the group, because size of anion is increasing, that is why according to Pajan's rule, the covalency is going to increase, right? So that is the order for covalency, right? Understood? The size of anion and covalent character are directly proportional. Which of the following order is correct for bond dissociation enthalpy of halogens? See, what we think is down the group bond dissociation enthalpy should decrease because the size is increasing, right? So it should have maximum, but in reality this does not happen. Fluorine will switch its position with over here in this position, and that is going to be your answer here. Fluorine, why it is going to switch its position? Because of electron repulsions. Okay, this bit we have done this, right? Okay, increasing order of acidic strength. Why I have taken up questions here? Because I know that you will forget everything once you do it, hai na? So when you see the questions, then you will feel that, okay, these concepts are actually there as questions, okay? Then you will, you know, have that feeling, okay, I have just revised this, at least I'm able to answer some of the questions, right? The correct increasing order of acidic strength here. Acidic strength, we know that down the group size increases. It is easy to lose the electron, hydrogen here. So answer will be down the group, acidic strength increases, right? Correct order of acidic strength in this. More the number of oxygen, more is the acidic strength, except for phosphorus, oxyacids. So more is the number of oxygen, more is the acidic strength. So answer will be B is the correct answer. Okay, more the number of oxygen, more is the acidic strength. Okay, is that clear to everybody? We have completed the major chunk here. Now we are just left with D block elements. Let me know in the comment section if you all are ready for that. Let me see how many likes without a break I am teaching you guys, right? So let me see how many likes you have given here, right? It should cross 300 plus likes, okay? Without a break I am teaching you here. Okay, from the past 3 hours. Oh my God. Are you exhausted? Do you want break? Or ma'am, let's finish this off, ma'am. Let's finish this, ma'am. How's the Josh? Let me know in the comment section. How's the Josh? How's the energy? Were you able to do questions? Were you able to do some of the questions? Were you able to do all the questions? How many mistakes you did, right? Or you were listening that, ma'am, yes, I was able to understand what you are telling in the concepts, how you're switching the concepts in the questions, right? Array, energy, energy, energy. Finish this, ma'am. Let's finish this, ma'am. Okay, 2 students are saying that, others as well. For that, I want to see your energies in the comment section, in the chat box. I want to see your energies here. Okay? Yes, everybody? Okay. Now let us see that D block elements. D block elements. Let's fill this chat box with green hearts. Okay? Uplift my energy as well. Fill this chat box with green hearts. By the time I think I need to refill my bottle here, right? It's totally empty, right? I definitely know that for next 1 hour, I need energy, right? For that, I'll just refill. So I'll just give you maybe 5 minutes break. Okay, so it's 1. So I'll see you all at just by 5 minutes, I'll join, right? Okay. You also 5 minutes means 5 minutes, right? So that is at 1:05 I am going to see you. I am starting the timer here, right? See you. By the time, start filling the chat box with green hearts. I should see green hearts filled in the chat box by the time I come back. Okay, everybody, I am back, everyone. Everyone, if I am audible and visible to you, let me know. Okay? Yes, everyone, I am back. I know I'm 2 minutes early. I think all have gone. They put their phone on silent and they're like, okay, ma'am, we'll see you at after 5 minutes. Let me see who are here, right? Okay, I can see the chat filled with green hearts. Let's wait for other students to join in back, right? Okay, so D block we are left with, right? It's a small chapter only, as you can see. Not too many things are there in this chapter, right? Okay, but yes, we'll do some very, very important things here. Let us do that. I think hardly 40 minutes maybe it will take. I think so in 40 minutes the lecture will end, right? Okay. So let us start that. Here you have D block elements, right? Okay. So D block, first thing you should remember for D block elements is that in D block elements, I'm going to tell you the things that you should remember for the questions, okay? So first is general electronic configuration is n-1 d10 n s1 to 2 electrons, and here what you will see for PD is the only atom where you have 5f0, where you have 0 electrons in the s orbital. Okay, PD is the only element. Rest of you will see 1, 1, 1, 1, 2, 1, 1, 1, 2, 2, 1, 1, 2, right? Again, here also you have 2. So in all the cases, you have 1 or 2 electrons. That is why general electronic configuration is in NS you will have 1 or 2. But in PD, that is the exception where you have 4F, 5F, 0. Right? That is the first important thing. Right? Next is, you should remember the 3D elements here. That is Saktiv, Karman, Fico, Niku, Jan. Okay. Fico, Niku, Jan. Okay. So that is the important part here. What you have to remember, this is 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Now, ma'am, how should we write the electronic configuration here? Okay, writing the electronic configuration of this one, right? Let us write the electronic configuration. Write 4s and 3d in all the cases. Write 4s, 3d in all the cases. 4s, 3d. How many of you know how to write the electronic configuration? Let me know in the chat box. How many of you are pro in writing the electronic configuration? And how many of you find it very difficult to write the electronic configuration? Those students also let me know in the chat box, right? So here it is 21, 21, 22, 22, 23, 23, 24, 24, 25, 25, 26, 26, 27, 27, 28, 28, 29, 29, 30 means 2 and 10. Okay, that is 30. 30 we will say 2 and 10. 3, 0 you can't write. Okay, so here it is 2 and 10. Now here the exception is in case of chromium and in case of copper, you will have different things. In case of chromium, you will have 4s1, 3d5. In case of copper, you will have 4s1, 3d10 because of the half filled and fully filled electronic configuration. This is going to change. This thing is going to solve your questions of magnetic moment that are asked. They will give you, and the questions of colorless, which will give you color, which will not. All these questions will be answered by this electronic configuration. Again, I am saying from DNF block, very rarely they will ask you any trend here. 2 trends are there, what they will ask you here, right? But these are the questions that they ask you, right? Okay, so from here, you should remember one thing, right? That is, I'll firstly teach you about magnetic moment here, right? Where is magnetic moment? I think it is not here. So I'll just write it here only, right? Okay. I'll write it here only. Remember one thing, that mu is equals to under root n plus 2 Bohr magneton, right? Okay. Now here, one more thing that you have to remember here is talking about magnetic moment. Magnetic moment, one of the questions, one of the most standard questions of NTA. Most standard question of NTA that they ask, right? So unpaired electron, if you have unpaired electron, tell me whether this para or diamagnetic. When you have unpaired electron, and this is when you have paired electron. When you have unpaired electron, that is paramagnetic. When you have paired electron, all the electrons are paired, that is diamagnetic. If they ask you the magnetic moment based on the number of electrons, so if you have 1, 2, 3, 4, 5, these are the number of unpaired electrons, right? Then the magnetic moment is going to be 1.7, 2.7, 3.8, 4.9, 5.9. Okay, this is how you're going to write the magnetic moment. You don't need to use this formula of mu is equals to under root n plus 2 Bohr magneton. You should remember this formula, but you don't need to use this formula because directly from the trick we can answer that what is exactly the number of unpaired electrons or what is the Bohr magneton from here, right? Then we will see that there are three elements that are regarded as non-transition elements. D block elements are called transition elements, but these three elements are regarded as non-transition elements because they have fully filled electronic configuration of d orbital in their excited state and in their ground state. Even in Zn2 positive, Cd2 positive, Hg2 positive, you have D10, that is fully filled electronic configuration, right? Okay, that is why. But I'm saying in ground as well as in excited, in both the cases, you should have 3D10 electronic configuration, that is D10 electronic configuration, right? Then what are interstitial compounds? These are some of the important points. Interstitial, small atoms like these trapped inside the voids, right? Non-stoichiometric and neither ionic nor covalent, nothing they are. They have high melting point. These are from the pure metals. Very hard. Some borides approach diamond in hardness. Very important line. Okay. Some borides approach diamond in hardness. Retain metallic conductivity. How they can ask you these kind of questions? Which of the following is not a property of interstitial compound? This is how they ask you these questions. Okay. Statement based questions. Then for why they form complexes, because of the smaller size and they can availability of vacant d orbitals in which they can change their because of this not variable, because of the vacant d orbitals the ligand can donate the electrons into this metal. That is why they show complex formation. In coordination chemistry, you will see only these d block elements, not any other element. Why? Because they have vacant d orbitals, right? Okay. Then alloy formation, because alloy formation, homogeneous solid solution they form, right? Because of similar radii, similar properties, alloys are readily formed by transition metals. They intermix with each other, right? Hard and offer high melting point like steel, bronze, brass that we use in our daily life. These are from the transition element only, right? Okay. Next is this table is very, very, very important. Let us see this table here. See, first thing is regarding the electronic configuration. This I have already told you what you're going to do. Enthalpy of atomization. How many of you have always ignored it? Tell me in the comment section, how many of you ignored it? Enthalpy of atomization. Recently, NTA has asked this question not in one shift, in 3-4 shifts of JEE Mains. In NEET, they have never asked. In JEE Mains also, I've never seen that kind of question. But now they are asking question on enthalpy of atomization. So directly they can ask you the same kind of question because we usually ignore this, right? Okay. So here, they will not ask you any trend here. You just have to remember which of the following has maximum enthalpy of atomization, that is vanadium. After this, let me just write the trend here, vanadium. After that, what you have? 515. Then you have titanium, right? This also done. Then you have 430, that is nickel, right? That is also done. Then you have cobalt, right? Okay. Then you have cobalt. Cobalt, you have from this only they have asked, na? That's why I'm writing it here. 225. Then you have 216, that is iron. Then you have 390, that is chromium, right? Chromium. Then you have copper, right? This is a very weird trend that they have asked. Na? So this is, then you have scandium. This also done. Now you have manganese. And last one is zinc. So this is the trend of enthalpy of atomization. I would really advise you to do this, right? I would advise you to do this trend because it is important, right? They might surprise you with the question of enthalpy of atomization, right? Okay, you should know maximum is shown by vanadium, minimum is shown by zinc, right? Okay, next is regarding the electrode potential. They ask you question on that electrode potential. Wait a minute, electrode potential, if you see regarding the electrode potential of copper, if you see electrode potential for M2 positive to M, for copper it is positive. From there they ask you the question which has the maximum electrode potential, that is the copper, right? Okay, then this M3 positive to M2 positive, they don't ask it on the values. Okay, then ionization enthalpy, and radius, right? That trend I have already told you when we were doing periodic classification. If you remember, we have already done that trend. Do you remember? V Coni, ionization enthalpy, it should decrease along the period. It should increase along the period. But for V Coni, it will be opposite, right? Okay. So ionization enthalpy we have already done, right? Atomic radii, students, as you can see now, this is an important graph here. Atomic radii, we know that firstly it will decrease till manganese, then for iron, cobalt and nickel it will be same, then it will increase, right? But what you will see that for 4D and 5D series, the radius is equal to each other because of the lengthenoid contraction, okay? Because of the lengthenoid contraction. Then for ionization enthalpy, we have seen the trends here that ionization enthalpy, if you see, it is following a very weird trend, right? That I have told you that ionization enthalpy will, if you want me to write it again, I can write it. So we know that sakti v karman fi ko ni ku jan. Okay, what I told you that it will increase along the period, increase, increase. In front of V Coni, it will be opposite. V Coni, it will be opposite. Okay, this is what you have to remember. Understood? Yes, everybody? Understood or not? Right? Now here, next is, in melting and boiling point, what you have to see? In melting and boiling point, from this graph, how they can ask you the questions. Okay, they will not ask you full trend here. How they will ask you the question? Tungsten has the maximum peak, then molybdenum has maximum, then chromium has the maximum. So these maximas you should remember. These maximas you should remember. And one more thing, that in 3D series it drops at manganese because of fully filled because of half filled configuration of D5, and at technetium also it falls down. Okay, so at these two positions it falls down, drop down. Okay, peaks will be tungsten, molybdenum and chromium, and at TC and Mn it will drop down immediately only in 3D and 4D series. Okay, these are the two important points to take away from the melting and boiling point, right? Okay, next is a very important paragraph here regarding copper. What has happened? Regarding copper, we have this very important paragraph here. If you can see this. Now, this question from copper they have asked, right? Okay. Now, the unique behavior of copper having positive E naught. Why it is having positive? This why I have told you that it has positive. Accounts for its inability to liberate H2 from the acids. It cannot liberate H2 from the acid. It is not very strong. It does not want to get reduced. Only oxidizing acids like nitric acid, hot concentrated sulfuric react with Cu. The acid being reduced. The high energy to transfer Cu to Cu2 positive. Now we are saying if you want to convert Cu to Cu positive is not balanced by hydration enthalpy. The general trend towards less negative E naught value across, and the same applies for this. Okay. Now we will see this to beta. This just ignore this line. Ignore this line. Okay. This line you can just ignore. Okay. This line you can just ignore here. Right. I'll tell you what you have to remember. Here we understood that, okay, E naught is very positive here for copper. That is why it is not able to react with any acid to liberate H2, right? But with very strong acid, it can do that, right? Because the hydration, that is the hydration energy that releases amount of heat, that is not balanced, that is not complete to convert Cu to Cu2 positive, right? Now, we will say on the other hand, now this is important. Cu2 positive halides are known except the iodide. Now we are saying Cu2 positive halides are known, right? That is important thing to remember, that Cu2 positive halides are known. Now in this case, Cu2 positive oxidizes, very important, I negative to I2. That is why we say that this is one of the questions in your exam, that Cu2 halides does exist, right? That is why Cu2 positive, if you have Cui, that will be converted to Cu2I2 and I2. That will dissociate. This is one of very, very important question, that Cui2 will be dissociated to Cu2I2 and I2, right? However, in many copper 1 compounds are unstable in aqueous solution and undergo disproportionation. Now they are saying that, but there are some important compounds that in some cases what happens, see, copper positive, we know that this has D10 electronic configuration. This is D9 electronic configuration. Now ma'am, why it is getting, why D10 to D9? That is the main important thing here. It should not have happened like this, right? But still it is getting disproportionated into D10 to D9, that means Cu positive to Cu2 positive. Answer is the stability of Cu2 positive aqueous rather than Cu positive is due to, why it is so? Assertion reasoning question. Why it is so? Because of the much more negative hydration enthalpy of Cu2 positive than Cu positive. Because the hydration enthalpy is released, that will possibly make this Cu2 positive more stable because of the energy that is released, which more than compensates for the second ionization enthalpy, because when it is 3D10 to 3D9, this energy will be provided by the hydration energy of Cu2 positive. Is that clear to everybody or not? Is that clear to everybody or not? Everybody in the chat box. Next is trends in stability. Now here what you will see, two charts. Okay, you don't have to remember everything, just remember one thing. If you see, when they are making halides or let's say fluorides, okay, manganese maximum oxidation state is +4. But when it is making oxides, its maximum oxidation state is +7. Reason? Because of the double bond, because oxygen can form, this question was also there, oxygen can form multiple bonds. Because oxygen can form multiple bonds, that is why with oxygen, manganese can show maximum oxidation state, but not with fluorine, it cannot show maximum oxidation state. Okay, understood? This is there, this what I was telling you is also here. The ability of oxygen to stabilize higher oxidation state is due to, same than this, wait a minute, demonstrated in the oxide, the higher oxidation number in the oxide coincide with the group number and is attained this, okay, beyond group 7, no higher oxidation state, above this are on. Although ferrates are formed in alkaline medium, but they readily decompose to this and this. So they are talking about which is the highest, that means higher oxidation state are very difficult to form, right? Besides the oxides, oxocations like these are also stable. The ability of oxygen stabilize, now this is the question that I was telling you. The ability of oxygen to stabilize these higher oxidation state exceeds that of fluorine. Thus, the highest manganese chloride is this, but whereas oxide is this. Here it is +4 oxidation state. Here it is in +4 oxidation state. Here it is in +7 oxidation state. Explains its superiority because oxygen forms multiple bonds. That is the reason here. Why it is so? Because of the multiple bonds. In the covalent oxide, each Mn is tetrahedrally surrounded by oxygen, including this. You don't have to do. Just look into this particular line here, right? Okay, that was important. Next is ionization enthalpy. Now, ionization enthalpy, one is the order, the trend of 3D series. Other is they can ask you which ionization enthalpy is greater. For that, just see if it is getting converted into a stable, half-filled or fully filled, then ionization enthalpy will be less. If from a stable configuration you are taking out the electron, then the ionization enthalpy will be exceptionally high. So here you have chromium positive, which is stable. So here that is why it has more ionization enthalpy as compared to Mn positive, which will get converted to 3d5 once it loses the electron. That is why for Cr positive, the ionization, for Mn positive, the ionization enthalpy is less. Similarly with Fe2 positive, you have this 3d5. That is why here in this case, you have, wait a minute. Yes. Now, if you see this here, in Mn2 positive, you have 3d5, right? Now, here it is losing, if it loses one electron, its stable configuration will break. That is why Mn2 positive have more ionization energy as compared to Fe2 positive, which after losing one electron will be converted to a stable oxidation state. So, most of the questions they will ask you in ionization enthalpy will be like this only. You have to write the electronic configuration. That is why in the starting only I told you that if you are able to write the electronic configuration, most of the questions you will be able to answer. Right? Now, which shows the maximum number of oxidation state is manganese. Right? That is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 oxidation states. Right? That it is showing here. Next, we have magnetic property. This already I have told you, right? Trick also I have told you. Now, let us see potassium permanganate and potassium manganate. What you have to do here. So, this is potassium permanganate, that is KMnO4. Firstly, you should know the structure here of KMnO4. It is isostructural with KClO4, right? This question was also there. Okay, it is isostructural with KClO4. Both have tetrahedral structure, right? Okay, in place of Cl, you have Mn. The rest of the things are same, right? And other thing is, what is the preparation? Preparation is from MnO2, and then you have the preparation of potassium manganate ion. Then you have the preparation of potassium permanganate ion, right? Okay. Now, next thing is that if you react this, very, very important, if you react this KMnO4 in acidic medium, right, it will give you MnO2, right? If you give it acidic medium hot, it will give you Mn2 positive and O2. But if you give it, let's say, I'll just write it here only. If you give it, let's say, KMnO4, basic medium, where I'm looking for basic medium. I'll see that. No. MnO2, oxidizing nature. Chalo, let us see this here. In acidic medium, right, what exactly happens? It can, in acidic medium, basically, if you see, it is getting converted from Mn7 positive to Mn2 positive. Here also it is 2 positive, here also it is 2 positive. Right, this is what is happening in acidic medium. I think alkaline medium should be there somewhere. Right, okay. So let me see, where is alkaline medium? Right, okay. In alkaline medium, it is getting converted to +7 to +4 oxidation state. Okay, weakly basic. And in very strong as basic medium, it is getting converted to Mn7 positive to Mn6 positive. So these are the three important things from where they ask you the question, that what happens in acidic medium, what is the change in oxidation state, in neutral medium, what is the change, in basic medium, what is the change in the oxidation state, right? Next is, they might ask you question from the, because it is a very strong oxidizing agent, so what all it can oxidize. So rest of the things are simple only, but this thing is very important, right? This thing is very, very important, that in, if you say I negative to I2 and I negative to IO3, iodate ion, this is in basic medium, this is in alkaline medium or neutral medium. So in alkaline medium, I negative to I2, in basic medium, I negative to IO3 negative, that is iodate. This is a very important question. Okay. Rest of this are normal only, that oxidation will occur there. Right. Next is K2Cr2O7. Right. First is it is prepared from chromite ore. The formula of chromite ore also they have asked. Right. That is FeCr2O4, the formula of chromite ore from where it is formed. Right. Then what is the preparation? Preparation step is that firstly you will have from the chromite ore, you will have the formation of yellow colored sodium chromate, right? Then you will have the formation of sodium dichromate, right? Then you will have the formation of, right? Then you will have the formation of potassium dichromate, that is of orange color, right? Next is interconversion. Now what in acidic, what in basic medium? So let us see that. CrO4 2 negative in acidic medium is converted to Cr2O7 2 negative, right? And in basic medium, it is this Cr2O7 is getting converted to CrO4 2 negative. They are interchangeable in the acidic and the basic medium, right? Okay, this you have to remember. Then if you say in acidic medium, this is simple thing is, in acidic medium, if you say the oxidizing property we are talking about, we have the acidic medium here. Then Cr2O7 2 negative will be converted to Cr3 positive, right? Okay, directly you can answer this, that in the acidic medium it is converted to Cr2O7 2 negative is converted to Cr3 positive. This they have asked, right? The number of electrons that are exchanged in the acidic medium. So here the oxidation state is +6, here the oxidation state is +3. Number of electrons change you can tell, right, according to that, right? Okay, rest is your, which is getting converted to which thing? Oxidizing nature. So Fe2 positive, basically oxidation number is increasing in all these cases, right? Okay, there is no different thing here that I negative will be converted to which part, I negative will be converted to which part. That is there is no exception in this case, right? Now let us do F block element. From F block element, what they ask you, simple thing is, firstly they will ask you lanthanoids and actinoids, right? So both, this is from after lanthanum, this is after actinium, right? Okay, then now in lanthanoids, chemical properties are that lanthanoid exists in La3 positive. So let's see, you have O2 negative, it is forming an oxide, so it will be La2O3, these kind of. Let's say you have hydride here, so it will be H negative, so it will be LaH3, right? Let's say you have nitride here, that will be N3 negative, so it will be LaN. Okay, so that is how it is going to form the different compounds here with the +3 oxidation state, because Ln in +3 oxidation state is maximum stable, right? Okay, now from this table is what is very important from you, from where they are asking you the questions right now. Okay, and that's why I can't see any comments. I feel like you guys are sleeping in the class or what? Are you guys sleeping in the class? There is no halchal, nothing going on. Chat box is completely empty, nothing, ma'am. Right? Very disappointing, guys. Very disappointing. Without a break, I am teaching you, but still you guys have no energy. Very sad. Now, let us see this here. But I sometimes feel like you don't have any appreciation, any love for Diksha ma'am, Dosa ma'am. Nothing is there. Right? Okay, ma'am teaches us, it's okay. Yesterday I slept at 3 p.m. Sorry, 3 a.m. Woke up at 7. Okay, so this is, firstly you have to remember the stable electronic configurations here. So I'll just write it. In +4 oxidation state, the stable is 4F0 and 4F7. That is cerium 4 positive. And here you have terbium 4 positive, that is having stable configuration. Then in 3 you will have 0, 7 and 14, that is lutetium 3 positive, lanthanum 3 positive, and then you have gadolinium 3 positive, that is the stable configuration. Then in the 2 positive you have 4F7 and 4F14, that means here you have europium 2 positive and you have ytterbium 2 positive, right? Ytterbium 2 positive, right? So these are the important electronic configurations that I have marked here. Cerium, europium, terbium, ytterbium, this you have to remember, right? Okay, yes. Okay, that's good that you guys are listening here, right? Only 3 students. Oxidation states number is 2 to 4 do occur. So now what you have to remember is that a noble gases configuration is cerium 4 positive, right? Half filled configuration is of EU2 positive and terbium 4 positive. Completely filled configuration is of ytterbium 2 positive. So these are the important points from the electronic configuration, right? Okay. Then, ma'am, do we have to understand the radii? No. Okay, just remember there will be lengthenoid contraction here that I have already told you, right? Okay, so you don't have to go through the patterns here, right? Next, we have this also we have done. This also we have done. And all these things we have done already, right? You don't have to go through actinoids, okay? Actinoids, they will not ask you the electronic configuration. Plus, there is very random electronic configuration here. So you can just ignore this, right? Okay, you can take that much risk. Okay, lengthenoids, I have advised you that do those electronic configuration, but this so you don't have to do right now, right? Now, one more question they can ask you is actinoids contraction is greater or lengthenoid contraction? So actinoid contraction is more than lengthenoid, because of 5f orbital have even poorer shielding effect as compared to 4f. So actinoid contraction is greater than that, right? So actinoid also they exist in +3 oxidation state. In everywhere you will see An as the +3 oxidation state. It is more stable, right? Silvery in appearance, highly reactive, especially in finely divided, paramagnetic, tarnish in air due to oxide coating, right? Okay, very rarely they ask you questions from actinoids, right? Okay, now let us do some of the questions. So everybody, now you were listening, now it's your time to answer. Okay, so all of you are ready or not? Yes, everyone, the last part of today's lecture, that is the question part. Ready for that, everybody? Ready for that? If you're ready, then let me know in the comment section if you guys are ready for that. Chalo, I'll get side. Okay, you think that you want to answer questions or not? If you want to answer questions, then I'll definitely do questions along with you. If you don't want to answer, then we will end this session. Okay? Totally your choice. Your choice. Because ऐसे तो I don't want to do the question. What is this? You know what I feel like when you're sitting like this? I feel like, do you want to answer? Do you want to answer? Huh, ma'am? What you said? Oh, I'm sorry, ma'am. I slept, ma'am, in between the class, ma'am. Okay. Now let us see magnetic moment, that is 2.84. Now if magnetic moment is 2.84, that means number of unpaired electrons should be 2 here, right? So that means if you talk about number of unpaired electrons should be 2, for that you should know the electronic configuration of all of them here, right? So titanium, we know that it is 22, so it will be 4s2 3d2. After losing 3 electrons, it will be 3d1. That means it is definitely going to show us only 1.7, one unpaired electron. Our unpaired electron should be 2. Chromium is 4s1, 3d, 5. After losing 2 electrons, it will be 3d, 4. Again, 4 unpaired electron. Cobalt is 4s2, 3d, 7. You take out 2, it will be 3d, 7. That means 1, 2, 3, 4, 5, 6, 7. It is going to show us 3 unpaired electron. Nickel is 4s2, 3d, 8. Now it is, after losing 2 electrons, it will be 3d8. So that means it is going to show us 1, 2, 3, 4, 5, 6, 7, 8. That means 2 unpaired electrons. So answer will be D is the correct answer. That will show us 2 unpaired electrons here. So answer is going to be D is the correct answer. Next is, which one of the following correctly represents the correct order of property indicated against it? Right? So they have indicated few properties here. They are saying which of the following will tell you the correct order of the property here. Okay, increasing number of oxidation states. Then you have increasing magnetic moment here. Then you have increasing melting point. Then increasing ionization enthalpy 2. Right? So let us see. If you see this, I'm not going to tell you the correct answer here. So why this is the correct order of melting point, right? So melting point of the transition is first rise to a maximum, then falls as the atomic number increases to manganese, then have abnormally low melting point. So this is the correct order of the melting point here, that is C. The basic character of transition metal monoxides follows the order. Basic character of transition metal oxides follows which of the following order? Right, so this is the order that is given to you. T, V, Kar, Man, Pico. Okay, so this is what is given to you. Now they are asking you the basic strength here. Right, all of them will have two positive charge. So you have to see which is able to have more electrons here, then that will be the basic character. Basic character of transition metal monoxides is T, V, Kar, Man, Pico. That means it is decreasing. Basic character of oxyacid decreases with increase in the atomic number. As atomic number increases, basic character will decrease. Oxides of transition metals in low oxidation state, it means +2 and +3, are generally basic except for Cr2O3. All the oxides except for +3 and +2 will be basic in nature. Right? Next is the acidic, basic and amphoteric nature of Mn2O7, right? V2O5 and CrOr respectively. So manganese, V, so you have already seen that this is amphoteric in nature. What about CrO and Mn2O7? Anybody? Anybody? So answer is going to be, this is acidic in nature, manganese. Along the period, non-magnetic character increases. Right, so here, non-magnetic character will increase, na, manganese. So this is V, this is manganese, Karman, Pico. So along the period, non-metallic character increases. So this is going to be acidic. This is going to be basic in nature. And here we know that vanadium is definitely amphoteric in nature. So answer is C is going to be the correct answer here. Next question is, match the following. Now this is a very repeated question, very famous question of DNF block, right? Try to answer it. Vanadium oxide, you have this Ziegler-Natta catalyst, PdCl2, nickel complexes, right? Try to answer it, students. Try to answer it. Vanadium oxide, that is used in which thing? Oxidation of ethine to ethylene, polymerization, oxidation of SO2. This I'll tell you. First is C. That means two options I have eliminated. Now out of these two, you tell me which is the correct answer. These two. Right? These two, you tell me which is the correct answer, students. Is the screen blur? These two, which is the correct answer? If you see, B is the correct answer. That is 2D, Ziegler-Natta catalyst that is for polymerization of ethylene, right? And you see the PdCl2 that is for oxidation of ethyne to ethanol. Then nickel complexes are polymerization of alkynes. Okay, so answer will be what you are answering, B. Very good. Next is, which of the following lanthanoid is diamagnetic in nature? Lanthanoid that is diamagnetic, which has unpaired electrons. See, very simple. We know that which of the following is diamagnetic in nature, which has unpaired electrons. So I think samarium will have unpaired electron, right? Because europium 2 positive, cerium 4 positive is definitely half filled or fully filled, I think. Right? I think answer should be A, samarium. Wait a minute, let me see. Samarium is what they are asking you. Diamagnetic they are asking you. Right? Diamagnetic means no unpaired electron. Oh, so sorry, my mistake. No unpaired electron. No unpaired electron. All the electrons should be paired. That is definitely in case of ytterbium, which has fully filled electronic configuration of 4f40. Right? Okay, so answer is going to be ytterbium is the correct answer, which has no unpaired electron. Again, this is from that table only which I told you. Right? Next is gadolinium belongs to 4f series. Gadolinium belongs to 4f series. Its atomic number is 64. Which following is the correct electronic configuration? Gadolinium 3 positive we have seen, right? It is a stable configuration, right? You add 3 electrons there and you will get your answer here, right? So answer will be this. Already is gadolinium. If you don't remember the atomic number of gadolinium, you don't remember the electronic configuration of gadolinium, what you have to do? We know that gadolinium was in half stable configuration like this. Gadolinium 3 positive was in half stable, right? So you add 3 electrons into this, then this will be the correct answer. Okay, that is how with elimination or by using some tricks here you can answer this. Otherwise, gadolinium is a very important compound that I have marked in that also chart also, so that you must do. Correct order of ionic radii here, right? So this again they have given us for the, here you can see that it was decreasing only, right? So according to that, the order you will see, right? Then lanthanum, then europium, lutetium, then this, right? That is how you will have the answer. The lanthanide series, there is a regular decrease in atomic number, right? As ionic radii of the trivalent ions as atomic number increases, although the atomic radii do show some irregularities, but ionic radii decreases from this to this as it is. Wait a minute, then it should not be the correct answer. They're asking you the ionic radii, right? Wait a minute. If you see this here, wait a minute. If we see this here, okay, that is that is not ytterbium. That is so YB, na? Ytterbium is YB. Okay, yes, ytterbium is YB. So that is they have given you from some 3D compound. Okay, so this is 39 atomic number, right? This they have given. Let me just show you the periodic table where they have given you this thing. This one. Okay, this one. This is why I thought why B it is written. Why it is written? Okay, so definitely here we know it is following a stable thing, but why we know that that belongs to 3D only, right? So here that is the reason it is going to have minimum, because down the group size is increasing. Down the group, this is from D orbital. This is from lanthanoids. This is from lanthanoids. In lanthanoids, the ionic radii is decreasing. But this is from D, so definitely that is above the lanthanum. So that is why it is less, because down the group we know that ionic radii increases, right? So that is why this is the correct answer. Which of the following statement is not correct? LiO3 is less. First statement is only not correct, right? Because it is the opposite, right? So here LiO3 is more basic than this, more basic than LiO3. Reason is in lanthanoid, the basic character of hydroxide decreases as the ionic radius decreases. Basic character will decrease here. That is why here this will have more basic character as compared to this LiOH thrice. Okay, so La is actually an element of transition series rather than lanthanoids. That is definitely right. Lanthanum is not a lanthanoid. That is belonging to group number 3. It belongs to D block. That is a very important point. Students usually mark this as wrong, right? So here it is. It should be Lu here. Okay. So atomic radius of zirconium and this are same. Yes, in lanthanide series, ionic radii of this ion decreases. That also we have seen that ionic radii constantly decreases. Right? Okay. Last one, I think this is a repeated question. We have done this before also, right? So maybe that was asked 2 times. So I is R, I is R, I is R, right? The students, you guys answer. Okay, we are doing this for the second time. Just 2-3 minutes back, I have done this question. Huh. Okay. Chal. I think you have done this because we have repeated this question. Okay. We have repeated this question here only. Here only we did this question. If you can see this question, we did it here. Right. We have already done that. Right. Okay. Okay, students. So finally, we have finished block chemistry. Block chemistry is done and dusted. Block chemistry is done. Block chemistry is done. Right? That is done. So, are you all happy with that? Right? We have completed everything from DNF block, periodic properties, P block, like we have done enough, right? And without any break, it was a task. It was a big task. It's been 4 hours, like I'm constantly teaching. And for that, I think I deserve your comments, okay? Now, once I end this live, fill this comment section with a lot of comments with the positivity all around, right? And I want to see you guys writing in the comment section hashtag NEET 2025 hashtag doctor and your name here. Doctor and your name here. I want to see that. Okay. Hashtag doctor and your name. If you are enough motivated that yes, I'll crack NEET 2025 and I'll have doctor in front of my name. Right? Okay. And for all those students who are looking for any crash course right now, you are thinking that, ma'am, I want proper day and night. I want full classes for my NEET for these 20 days. So even right now, right, the batch, the revision is starting to the next level only, right? So NEET 2025 crash course is already there, right? That is going on right now. She'll get all the detailed lectures that we have taken before as well. And in the live classes, doubt solving, previous year question discussion, everything is going on right now at this point, right? So you can go and attend this. This is just for 1199, right? Test series, everything will be available in this crash course only, right? Then for NEET 2026 aspirants here, right? So students, this is our DNA batch that we did in 2025 as well. So now new DNA batch for 2026 student is right now live, right? You can ask your juniors, right, to join this batch, right? If you feel that yes, this is the content that we provide you is a good content, then definitely recommend this to your friends, to your juniors as well, right? And that's it for now. I think that's it. Okay. Now these are the some important playlists for you. Pre-COVID pattern backlog series. So you can go through all these things here. right? Okay, so you can go through all these things, the previous lectures that we have already taken, right? Now, I'll see you all in the next session. I want to see the chat box, the comment section filled with comments, and see you all in the next class. Till then, bye-bye. Take care. This is Diksha Kaushal signing off. Bye-bye.